We are running the 2 tracks event, and we will start with the 30 minutes sessions with some 10 minutes Q&A sessions, and we will have 2 breaks. After the event, we will have some socializing event where we could stay and share the experience. I really wish you a pleasant day, and I will going to wait for the people here and then hand over for the first speaker. So let me check, is it fine for the start? Okay, still need some time here. Yeah, we are checking the audio and then screen sharing. And if you have any troubles, you can tweet us in a Twitter for the uh, hashtag DevFest, or also using our website and use the um, email for help at DACH DevFest online. Yeah, so we are still gathering here. Just a couple of minutes and we will start. Okay, so I see that we are ready and we could, I think, invite our first speaker. Just a huge round of applause for the Ole. And yeah, I can see him. Hey, hello.
So I think I should start now. Thank you. I'm doing a bit of a blind flight here today. Sorry. Welcome to my talk. So I want to share why Go is becoming so popular. So what's interesting about it, what sets it apart from other programming languages, and in the end, how does it handle complexity? What can you do different there? Since this is usually the end game, kind of. Right? Every project is great until it becomes really complex. And so let's take a look at that. Yeah, a bit about me. I've been doing lots of software development many years, co-organizer of the Berlin Go meetup, and now let's start to go into programming. This is a little Go program. So every Go program lives in a package. The main package is where it all starts. So function main in a main package is where the entry point for every program is in Go. And so what we want to do here is reading a file. It's quite simple, straightforward. There's a read file function that you can call, give it the name of the file to read, and then you get the content back plus an error, possibly. Then you handle the error, and finally you can do something with the file content. We just print it here again. So what does it all tell us? This is quite boring, right? Because you can do this in almost any programming language, probably. JavaScript is a bit of an exception because it offers only asynchronous I/O, which is great somehow because it allows better scaling. And it looks a bit between a scripting language and a traditional compiled language. Not many types would have to be given, but yeah, nothing too special. But what would be cool instead? Asynchronous I/O, as JavaScript has, would be great because it allows for higher scalability. And of course, you want to use the time while waiting for I/O to perform other tasks. And no garbage collection breaks or very, very short ones. That would be great. And Go is using garbage collection, but it is indeed very short. And Go Go is doing all of this behind the scenes. And this is the kicker about Go. It looks like a boring, simple, straightforward language, but under the hood, it is doing all this cool stuff. And this is why you can do high throughput, low latency servers with Go. And they are still quite maintainable. We don't need callbacks or reactive libraries or anything special. And the same goes for network I/O, of course, any kind of I/O. And yeah, as I said, this allows high throughput, low latency services. Go is very simple in this way, right? And because this is one nice thing, the foundation for Go becoming the language of the cloud, but you as well need some resilience, right? And this can be very tedious. And with Go, it's a bit easier. I quickly go over here. So when you do a Google search, like you want to implement that, you want to search in parallel for web results, for image results, and for video results. And you want to do that in parallel. So you start 3 Go functions, Go routines in Go. So these run in parallel. And whenever one of them is stuck on some I/O, one of the others would be run on the same processor. So even with a single processor, this can save you a lot of time. And you want to have a timeout because you want to hand back results quickly. We chose here 80 milliseconds. And you want to have 3 results, so loop until 3. And every time we get a result from the channel that is written in one of those, we would append it to the results that we return in the end. And in case of a timeout, we say, sorry, timed out, and return the results as they are until then. And if the loop ends normally, so we got all 3 results, it's returning immediately as soon as it got all 3 results, right? So this is a way to do this. And this first is interesting too. You want to have multiple instances, since sometimes the server can be slower, there can be some problems. And so companies like Google have multiple running in parallel with the same content. And so for web search, we have got 3 replicas here and 2 for images and videos. And the first result is taken. And this is implemented in a quite similar and simple way. You create a communication channel, then set up the Go routines that write to the channel, and for each replica, sending the query string into it, and then it sets up the Go routines for each of these replicas, and the first result that appears on the channel is simply returned, and the channel is cleaned up automatically. And this is all you got to do, and you got a quite resilient and stable system already just by this. And yeah, more resilience patterns, timeouts are handled with the help of the standard library nowadays, so you don't have to do that much at all. And others are implemented usually in open source libraries. And so they all work in a similar way, usually no logs, no mutexes or whatever things you usually have to do in other languages. Other features in Go. Now we go into the direction of complexity handling a bit. So layers of abstraction, we try to avoid them as much as it makes sense. So we think about in Go, what would be a good API, And underneath, we try to avoid layers of abstraction and make something nice to use, but not additional layers of abstraction, because it is some pattern. So we try to avoid these famous patterns. Yeah, most of the standard library is only like 1 to 3 calls deep. And I never had to debug more than 5 calls into any dependency that I used. And of course, in business logic and big servers, you can still have more, but it's try to avoid it. Most functions fit on a single screen, so you don't pay by not having many calls deep, but huge functions or so, you can still understand them quite quickly. They are not like 3 lines often, sometimes they are, but often they are more like about the screen size. And even the heart of the runtime system, the switching of the Go routines, it's quite simple. It's about 1 screen full of code, bit dense, but it is possible to understand it, how this is done under the hood. And the whole function is a bit bigger, at least 2 screens full, because of some special edge cases and setup and so on, but it's not that huge. And yeah, bugs and dependencies can be discovered quite easily, since you can simply step into code and find something. And yeah, you can fix it and then hand in a pull request, and this usually gets accepted quickly. I just did this 2 weeks back. So, but in the end, there is no silver bullet, of course, since complexity is the huge thing you have to do something about. And yeah, all the neat code in the small can't save you from when it's getting really big. But simplicity is a North Star, so we try to shave something off of it wherever possible in Go. And we got this proverb, do less, enable more. So we, instead of handling a lot of edge cases in a function, we rather do the straightforward things that are the heart of it, and then have a lambda, a callback function that does all the special handling then. And so the function itself does less, but enables more, because this callback function can do way more special things than we could implement easily in the function itself. And yeah, let's take a look. How does this scale? So in the old days, we had only monoliths, right? It was 1 deployable unit. Yeah, operations insisted on it. Well, never been questioned really. And yeah, these systems grew without bounds. Many still remember, suffer from it, usually becoming a big ball of mud. So quite unmaintainable, huge thing. And this looks something like this, the crazy thing in the middle. It's really hard to understand anything there, or like that. It's even more wild, and yeah, you don't get a real chance to understand anything. And I have to talk a bit about Java, since this is the language that has been most used about it. I've been using Java for almost 20 years myself, so I know still a bit about it. It allows circular dependencies between classes. Of course, for some programming patterns, you need them really. And this is a big thing. It allows circular dependencies between packages too. And packages are the biggest structure we have in Java, really. And when circular dependencies are allowed there, it's hard to follow and give it structure. The compiler doesn't help us much there, unfortunately. And yeah, between projects, it's not encouraged really, and it's rare. I think it doesn't bite one really, but I don't think it's really prevented either. So how can we handle tools complexity the traditional way? You can use structural analysis, so IDEs are quite good for that. Rename classes, all these refactoring things, right? Move functionality around, extract methods, and so on. Big companies have their own specialized tooling. Google is really famous for this. And now we get microservices, right? We don't want this huge thing anymore, this big ball of mud. Now we have one system with 1,000 deployable units sometimes. And yeah, this is the thing we have to do now with DevOps and clouds, and I've seen it rarely being questioned. Systems still grow without bounds, and now it becomes spaghetti architecture instead, right? So no spaghetti code because the services themselves are too small, but inside, outside the relations between all the services are really a lot still. And one part, let's see why and how things are split up in microservices usually. So one good reason is one part must not take down another one, right? If I have a big monolith and there is one small side part that goes down, causes a seg fault, it would take down the whole monolith. And then this would be really bad for resilience. And we don't want that, of course. That's a good reason to split. Another one is if some parts have to scale widely differently. Often it's you got a front end that has to scale for millions of users, and then a back end that has to scale only for very few users, like 10 to maybe 100. And this is something that makes sense to take apart. Then you can install the front end separately on many servers and the back end only on like 2 or so. And parts are really independent. Yeah, if it's getting really big and you got some parts that are truly independent, well, then please take them apart. But you don't have to, right? And another reason often used is to prevent this spaghetti code of this. They don't want this big ball of mud. But maybe that's not the best reason, right? There it's getting a bit vague. Maybe you can achieve this in a different way. And another reason is because it's too cool, because everybody's doing it, because you want to be modern too, and so on. Yeah, this is maybe the worst reason, right? If you don't have a real reason for it that really applies to your context, maybe this is not such a good decision then. Let's take a look at an example. So that tries to use cool new stuff, implement services in the CQRS pattern because it should scale better and helps us split services even more and nicer and so on. And yeah, so let's take a look what this looks like. Here we are. So when we got a microservice, we got lots of services. So, and here we got services like for bank transfer and a command and a query service. This is the CQRS pattern. You split the write request, these commands, from the read request, these queries. And it's a bit like I said between front end and back end, right? The front end is often the one that is doing the queries, the read requests, and they have to scale a lot, like looking at products in a catalog, like searching for something on Amazon or so. And then the command is where you really place the order. This is doesn't have to scale so much, right? This is much rarer. And so you get difference there. and you split up everything like that. And then you get a lot of services quickly, and they all look quite uniform usually, right? You got one executable, you need to access the database a bit, you need to message around, you got a service package that contains the business logic, and yeah, you need HTTP, so web access, where you implement the HTTP routes that where you receive the calls from the UI. And so it just doesn't give you a hint how this is structured. These are all independent projects, and it's really hard to find out how a complete flow, purchase flow in this shop example, how does this really work? You can guess, but it's really hard to find out. And after a while, you usually get some additional services here and there that are not that obvious from their names, where they are and how they are used and so on. And the only way to technically find out is either looking at all the messages and grabbing around there for who is using the message type that you are interested in. Or there are these systems like Jaeger and so on, where you can observe what's happening in real time in a production system or so. But then you have to set up a lot of infrastructure for that. And this is way slower than in the old monolith, where you could just with a mouse click ask for all the users of something. And so this can give quite a headache already. Let's take a look what other things can happen there. Yeah, this is really a service diagram from Uber. So I have to admit, it's impossible to find class diagrams, traditional class diagrams of monoliths. And so I took this service diagram from Uber. It's from Introducing Domain-Oriented Microservice Architecture, but it still stands, right? You don't understand much what's going on there. And this is from Monzo, their famous blog post, How Does Monzo Keep 1,600 Microservices Spinning? Go Clean Code and a strong team. Yeah, with them a very strong team. It's really hard to find your way around such a system. And yeah, the downsides are, as I told you, the providers, especially users of data, it's really hard to find, to know who are the other systems I'm interacting with, really, without it being obvious. And updating dependency with 1,000 microservices is even harder. You can do it in many little steps, which is nice, but it's really, really hard. It's a lot of work, very tedious, and usually they diverge. So you maybe agree on a set of dependencies, like libraries you want to use everywhere, but every service is using kind of a different version of it after a while. And this can make it impossible to merge back something together again. This is really, really difficult. And moving functionality around, this is something your IDE would do for you in a traditional monolith. But here, you can just copy paste. They are completely different projects. There's no way you can have an IDE do this for you. And cutting services in a different way is practically impossible. The only thing that I've found once that has been working is throwing all the code together, first to a monolith, and then split it up again. And this is, of course, something really, really crazy. And you probably never do it. Most companies simply declare it's okay, it's not that bad. You don't have to cut it in a different way. And so what might be a future way to go is a monorepo with some services. So you have one system with some deployable units. So you still got some of the downsides of a monolith, since you have a single repo, but not that much, since you have multiple services for resilience, for scalability, and if things are truly independent, but not just because it's possible. And yeah, DevOps Cloud are quite great for this. And of course, systems still grow without bounds. But how can we prevent a big ball of mud now? So let's take a look for how Go can help us with that. So generally, Go has been engineered for scalability, and the packages are made for encapsulating functionality. You can't break into a package later. Package is a unit of compilation, and you can't change it afterwards. Dependency cycles between packages aren't possible. This is one of the big things, I think. This is the similar to Java. This is the biggest unit you got in the programming language itself, but you only are allowed to have a hierarchy, and cycles aren't possible. And you can have additional tooling to prevent more cycles or more dependencies that you don't want to have. And let's take a look how this can be done. So I got a tool that I want to show you quickly. You can configure it. You can have two packages. So I say everything under X is a tool, which is the standard in Go. And then I have an additional package entities that is tools that will be used anywhere. And then I have something in between, which can be used almost anywhere, but is using the tools itself. Is in the front end, I want to handle customers almost everywhere. In the back end, the catalog data I want to handle almost everywhere. And I want to prevent a huge package. So I say the maximum size allowed is 1024. The tool tells you how big your packages are, and then you can adjust it. And it's measured in a measure that's independent of formatting or splitting up into multiple files or something. It's measuring packages and not how many comments you got or something like that. It's independent of that, not simple lines of code. So it's really measuring complexity. And so how does the project look like now? So we got the backend and the front end. As I thought, you might make sense to split it like that. So the front end does the shop front end as an executable. It handles customers, which are used a lot around the system. It's doing the payments, main transfers, credit card, PayPal, vouchers, and of course, a shopping cart. Something is missing in here, right? We don't have the catalog. We can't look at the products that we want to sell on the shop. How do we do this? The catalog is part of the backend. And well, it makes some sense since it's changed in the backend. It's you can add products there, you can even remove them, and then nobody can buy them anymore, and so on. So it's owned by the backend somehow, but you want it to scale with the front end. And how can we achieve that? Well, the backend has two executables. One is the normal backend of the shop, where that contains all the routes. And then we have a back for front. This is the back end part that is really for the front end. And this allows us to package only the routes that are needed for the front end, this reading of the catalog. And and then have it deployed with every front end together and let it scale together with the front end. So this can scale quite nicely, and still we get the code together with the rest of the backend code. So it's easy to change something in the reading part of the catalog, and it's not somewhere completely different, and I make a small change for the write part, and I forgot about the read part or something like that. It's not a completely different package. It's easy to do. So this should be good for maintainability. Besides that, we got recommendations and statistics for customers and products. And yeah, this is the whole system. It's not too difficult to understand, and I think you get these 3 executables in the end. It's not too big, and you can still find your way around there. And yeah, this is something that might be a good compromise. So let's take a look at this tool more, the spaghetti cutter, because there it helps with this spaghetti code, as I told you already. So next to this configuration, you get this dependency table out of it. It's automatically generated for you, and it tells us, for example, this X logging is a tool package, as we configured it like that, and this is imported by literally everything else, right? This is imported everywhere, so it's a tool package that's okay, and these entities are imported almost everywhere, right? They aren't needed for these recommendations from external sources and some other things, but they are used a lot. And we got the executables that import a lot of things. Yes, the main packages, that's their role, to gather things together and plug them together. They are big, but they plug all the stuff together. And this is fine. So you can see the structure here. And even if we wouldn't know what kind of package it is, we can find out this way, right? These things that are imported a lot, but aren't importing anything themselves. So I can't find them even on this site. They are tool packages, right? And so on. So I can generate such a graph at first, and then I can just declare everything here as a God package. That's what we didn't use yet. And God packages can import anything, are allowed to do anything that the compiler allows. So no circular imports, but beyond that, they can import anything. Only the main packages are God packages by default, and I can declare anything to be that. It's a simple, do a star instead of a single star, and then I got everything. And I can look at the graph and then see, these are tools and so on, and start giving it a real structure. And then I can rather quickly come up with something that's nice. And here I got some additional allowances. So email package is used by the user service to send lost password request emails and so on, and similar for customers and payments. When you successfully paid, you done the purchase, you get an email, of course, things like that. can be done, and it's not too much that you have to do. Usually around a screen full, for big projects a bit more, but it's quite easy to understand, and for new people it helps a lot to get into a project and understand how it's structured. So you can break up this monorepo or monolith a lot like that, and it can't work for microservices, unfortunately. I don't know how to build something like that for microservices. That's the problem. So let's see what we get in the end. Yeah, this is an open source tool, ready to use. I want to release version 1 in February, just some tests missing. It's a command line tool, so for CI/CD pipelines, development machines. You can use it locally, of course. Prevents code with error messages, return code, not zero, and it gives you this automatic documentation. So it's pressing the red button when something goes wrong, right? And yeah, let's see in the end. I think the Go programming language is encouraging simplicity wherever it can. Microservices are simple themselves, but overall you pay a high price. And reasonably sized services would be a great compromise. And tools like Spaghetti Cutter, I think, can help you preventing spaghetti code. And please enjoy your pasta in nice bites. So, thank you. I don't know if I could get questions. I don't hear anything yet.
There is
How
no
do I
question,
get
but,
sound?
Do you hear me?
Sorry.
No problem. Do you hear me? Okay. So we'll check for the questions. And so far there is no more questions. Yeah, but I think it's a perfect talk. It's a perfect beginning, and it's super nice and really exciting for the.
I can read questions here. This is good.
Yeah. Okay. Okay. So, but I see that I just very thankful for you, Oli, for your time today, and I think this is the right beginning of the track. And so far we have no more questions at all. But if there is any, you can directly contact Oli. His contacts on the website, and you can also repeat the questions here in the chat. So we will contact Oli and ask him for the writing the answer. Also, we are in nice shape for the timeline, and we have a additional break, I guess, for the next speaker. We still have time in Shadow, so still wait for the questions here. You, I believe there is not many questions right now, but I hope there will be some, and then we will ask you only for the answering them. So, yep. Then I guess that's it. Thank you so much. Thank you so much for the talk. And what I will do next, I will check the time, and we have still 10 minutes for the next talk. Let's get some exercise, some break, and we will be here at 11:55. Wait for the next speaker. Here is the Anna Rosenthal, and see you there. So we are here, and I think it's a nice time to continue our track 2 that are dedicated for the cloud DevOps and some backend engineering. And we have really nice speaker that I want to introduce you today. It's such a pleasure to say that the next talk is about the Golang also, and the topic are covered for the Go pipelines, the dangerous beauty of the Go. And our speaker is Anna Rosenthal. She is a backend engineer who previously worked on Java and Go microservices and Google Cloud Platform infrastructure at startups and in New York City. And she started coding in Go just a year ago. So, big round of applause, and we are welcome here, Anna. Hey, hey, how are you?
I'm doing great. Can you hear me okay?
Yeah, I'm very well. Great.
Awesome.
So, where are you now?
I'm actually in New York, which is why it's so dark here. I'm sorry.
Wow. Nice. We have here in Munich is pretty nice Sunday with a good weather. What is the weather outside in New York?
It's above freezing, which is really nice, but it's supposed to snow tomorrow.
Good. I see. So winter time. Okay, so let's start. I will hand over to you, and now we can start the talk.
Great. Hi, everybody. Thank you so much again for the awesome introduction. The name of my talk is Pipelines, the Dangerous Beauty of Go. And I just want to introduce myself very briefly. So, like Evgen said, my name is Anna Rosenthal. I'm a backend engineer living and working in New York. Here's my Twitter handle if you ever want to meet me. My DM is open. I'll be happy to hear any feedback from you. And like I also mentioned previously, here are all the technologies I worked with. And more recently, actually, I've worked with a lot of Google products, some of them being Go, GCP, and GKE. A few fun facts about me too. You're probably asking yourself, what is a developer from New York doing at DevFest DACH? And the fun fact is that I actually grew up in Germany, and I was in Berlin last fall when I submitted this talk. So I just want to say a huge thank you to DevFest crew for accepting my talk. And while I'm fluent in German and Russian, I could not give today's talk in either language, so you're stuck with my English. Outside of work, as you can tell in this picture, you can probably guess, I'm very passionate about recycling, public transportation, libraries, and gender equality. I like classical music, Dutch bikes, and German bread. Without further ado, though, I want to give a quick intro who this talk is for and why I chose to talk about this topic. So my talk in general is for Golang beginners. Ideally, I would love for you to be familiar with types, slices, functions, and maybe even anonymous functions. But if you're not, it's okay. I'll do my best to explain it and hope you're smart enough to pick it up on the fly. And since this is a talk about a concurrency pattern, it's hard to talk about concurrency in Go, not explaining how concurrency in Go works. So I'll introduce very general concepts like processes, threads, concurrency versus parallelism, and I will also go into very specific Golang implementations of concurrency and how it's being achieved in Golang. And this is how we're going to do it. First, we will talk about threads, then Go routines, channels, and then we will go over an example, a very simplified example of pipelines. I do want to highlight the fact that I will not go into testing of pipelines, and I will also not go as much into error handling. I will mention, though, the danger of it, and here's the dangerous part of it. But that's a whole nother talk in of itself. I just want to introduce this pattern to somebody who is probably starting out with Go and is curious as to what is the power of this language. And a Go pipeline is something I implemented in my previous job about a year ago when we were trying to process high batches of actually BigQuery tables and write out new BigQuery tables. And I found this pattern very helpful and very performant and powerful when it came to batch processing of data. So at a minimum, I would like for you to get some understanding of how concurrency in Go works. So you know some terms, and you can have a conversation about it. At least you'll get curious about them. And at a maximum, I'd love for you to get an understanding of a pipeline pattern, and ideally play around and try it for yourself. I will be putting up the slides later on probably my Twitter, or you can also just tweet me, and I'd be happy to share them with you. So let's actually go back to very basics, and let's discuss what a thread is. So as you can probably know, our computers can do a lot of things. I can be talking to you, I can be sharing the screen. I also have a calendar app running in the background. And that is because our operating systems can run multiple programs at the same time. This is being possible thanks to processes. So process is something that executes a given program. While it's the number, this is the overarching idea of doing multiple things at the same time, the cool thing about operating systems is that they can also run subtasks within processes, and those are called threads. So you can think of a thread as a slice of a process itself. Every process triggers at least one thread at a startup, and that's called a main thread. And then according to the needs of the program, or the programmer's needs, additional threads may be spun up, and they can also be terminated given the resources. And multi-threading is this big concept that people like to talk about, and it's an idea of running multiple threads within a single process. And if you're curious about what that looks like, a quick thing for you to test that out for yourself is to look for Activity Monitor on your laptop. And if you see at the very bottom, it actually lists all the processes and all the threads. And if there's one thing you're going to remember from the slide is that the count of threads is always higher than the count of processes. And they all have a unique IDs. And then again, if we look at the bigger picture, here's an operating system. It has a lot of processes, and each of them will house their own threads. I do want to briefly mention how memory is being managed in this case. So each process has its own chunk of memory assigned by its operating system. And by default, that memory cannot be shared with other processes. So my browser, for example, has no access to the memory that's being assigned to my Spotify app, and vice versa. And the same thing actually happens if we run two instances of the same process. That is, if I have multiple windows of Chrome or Safari, and the operating system treats each instance as a new process, and it dedicates its separate portion of memory to them. And by default, two or more processes have no way to share data. However, the cool thing about threads is that they can actually share memory. So threads share the same memory assigned by the parent process, and data, for example, in my Spotify main interface can be easily accessed by my playlist, or by by showing me the picture of an artist, or queuing up the next song. Therefore, it's much easier for two threads to talk to each other, and they're usually much more easy to manage from operating system standpoint. They're lighter than a process, they take less resources, and are faster to create. And you probably, I don't know if you're asking yourself, but you might want to ask, why would a process employ multiple threads? And that's the idea of doing things in parallel, and that's because doing so makes it so much faster for us to accomplish things. Now, I want to briefly introduce the concept of concurrency here. And it kind of goes along the concept of structuring program in such a way that it breaks in the program into pieces, and those pieces can be executed independently. There are a few things that kind of get dangerous if we don't do it right. Some of them are race conditions. There's also deadlocks. And if threads don't finish in the same order that they were initiated, by design they're asynchronous, we may get some memory leaks. And it's important to remember that each thread initiates and finishes at its own pace without regard to other threads. So because they don't really know what other threads are doing. Things may get dangerous. And just like to briefly mention, the most common form of race condition, that's when multiple threads try to access the same piece of memory at the same time. And the problem with this scenario is that many operations can be ignored, or worse, our memory can get corrupted. A quick plug for a really awesome tech talk by Rob Pike, which some of you might have heard. If not, I highly recommend you check it out. I don't want to steal his thunder. He has a great talk about concurrency versus parallelism. And to give you just like a very basic, maybe very brief takeaway for me, is just concurrency is dealing with lots and parallelism is doing lots. The two concepts may sound very similar, but I would encourage you to understand what the differences are. And I will just briefly mention one more thing, is that concurrency means that the application has more than one thing to do at the same time. And it's about creating multiple processes executing independently, while parallelism is about running pieces simultaneously. And here comes the time for actually discussing how concurrency, not parallelism, is achieved in Go. There are three, mainly there are two things, but we'll actually add one more thing that I'll show to you for the context of a Go pipeline. But very fundamentally in Golang, they're achieved with the help of Go routines and channels. So if you remember the time when I explained to you what threads are, Go routines are lightweight threads. They're a wrapper on top of threads, and they're managed by Go runtime rather than the operating system. Go routine in of itself is much like a thread. It accomplishes multiple tasks, and it's extremely cheap. They're multiplexed to fewer number of OS threads. So there could be one thread, and it will have thousands of Go routines. If we compare Go routines to threads, they have a faster startup time. They can communicate with our routine, with other routines with lower latency, and they're independent from hardware. And of course, how would it be not a tech talk without me showing you some code? Here's an example of Go routine, and I want to briefly explain what makes a Go routine Go routine. So if you first look at the very top of the very top line, we can actually add this keyword Go that I've highlighted in turquoise, and in front of any function execution, this would turn this method, getUp10, and it will add concurrency to the execution of this method. Funny thing, this reference actually is a reference to a rap song. Like I said, I like classical music, but sometimes I like to use references to rap songs in my code. The line goes, knock me out 9 times, I'll get up 10. So the interesting part about if we were to run this piece of code, and you have to trust me, and I hope you will actually prove it for yourself afterwards, we will get nothing. This function, even though we're trying to print on line 3, get up 10 times, this code will return nothing. And that's because after the call, go get up 10, so the only call that I'm doing in the main, the control returns immediately to the next line of code without waiting for the Go routine to finish. So there are 10 of them. I start them off, I fire them off, but never wait for them to actually complete. And then the main Go routine terminates, the func main terminates, and there is no other to execute. Hence, this method that I ran never actually get a chance to run. And then if we do want it to run, there are multiple ways for us to do it. One way for us to do it actually is to use a sleep function. Here I will, just like in the previous example, the difference is only that I'm adding this time sleep. I will start the Go routine, I'll wait 4 seconds, and then I will print the final line afterwards. And the reason we will get, you can actually see in the next clip what the result is, but the cool thing is that once we call the go get up 10, there is enough time to actually execute all of those routines within those 4 seconds and print the main function. So let me show you actually. This is my first time trying to run it for you. So let's see if we could run this clip. Running into my favorite terminal. So as you see, like they get printed 9, and then now we will get the main output from the main function. Now let's talk also briefly about, I hope, hang on, don't want it to go in loops. I want to talk about channels. And channels is also a cool Golang mechanism to communicate within Go routines. You can think of them as bridges that can send parameters to different Go routines. Channels can do 3 things. They can send, they can receive, and they can close. When data is sent to a channel, the control is blocked in the send statement until some other Go routine reads from that channel. And that's a very important concept that actually eliminates a lot of danger that we previously talked about related to multithreading. And similarly, when data is read from a channel, the read is blocked until some Go routine writes to that channel. By design, channels prevent race conditions when trying to access shared memory using Go routines. And this is the property that actually helps them communicate effectively without the use of explicit locks or conditional variables that we're maybe familiar with other languages. For example, I'm familiar with Java. And just to highlight this point again, there's no storage capacity in channels. They're just mechanisms, they're just means to send or write information. And the message must flow from the sender to receiver immediately. They cannot store anything in them. And if there is no receiver, then the message is stuck with the sender. And the data available inside the Go channel is accessible to a single Go routine. So there is a one-to-one relationship between the sender and receiver of the data. And if we were to briefly look at the code of what it looks like, here on the very top line, I'm making a channel of type int, and that's a pretty important important highlight in terms of types as they're going to come in later. In the second line, we're reading data from a channel. So the arrow shows the direction of the data that it's going. And the line above, we're actually writing to data. And then at the very end, we're closing out a channel. I just want to say one important part that channels can be actually buffered. And by being buffered, that means that they have a specific size of information they can hold. In this example, and the examples to follow, I'm actually using unbuffered channels. If we buffer them, we have a more flexibility, more control over how we synchronize them. But for now, you don't have to worry for this presentation. It's a very cool thing, though. So here comes the dangerous part. There's one thing that can happen when we're using channels, and this is the deadlock. Since Go routines have their own mechanism of managing memory access, channels actually is a thing where things can go wrong. If, for example, we imagine a case, like I said, if Go routine is sending data on one channel, that is expected that some other Go routine will be receiving this data. And if this doesn't happen, then we end up with a runtime and a panic. Or we end up with a panic at a runtime and a deadlock. And just like in a similar fashion, right? If something is receiving a data, and then some other Go routine is expected to write data on that channel, and if it's not happening, then the deadlock will panic. And of course, I want to show you what that looks like. So if in the program above, we have this channel ch that's created, and we send just an integer 10 to that channel. In this program, no other Go routine is receiving this data, right? Because the data is only flowing to the channel. And because of this, we will get this fatal error that all routines are asleep, which is not exactly, I mean, partially some of them are asleep, but what's actually happening is that sends and receives are blocking by default. And this means that once the data is sent to a channel, the control is blocked in the send statement until something reads from that channel. So the way we could resolve this, we could actually add a buffer, like I said, to hold this data, or we can, the easiest way for us to resolve this is to actually have a Go routine receive this data from this channel. So I wanted to do like a very German reference example here, and use using the channel. It could be like a lot of code to read at once, but if we kind of maybe like start in the main, we're creating this channel called done. It will start a Go routine called make money, and we will close it with this line of code done. This receives the data from this done channel that we created before, but it doesn't do anything with it, right? Like it's just a way for us to consume the data that we're sending from above. And that's a way for us to prevent this deadlock. And that's a way for us to actually print the line down below, which is 25 cents. So nothing is really blocking the sends, and our rates aren't blocked as well. And this way, the output of this function is first going to be fund, and then we're actually going to get 25 cents right below. And now the highlight of the stack, hopefully, is how we're going to piece all those concepts together and use a pipeline. Because an idea of pipeline, it's a kind of concurrent program. There are honestly many of them, but pipeline is a way for us to orchestrate channels and Go routines to, like I said previously, for example, process streams or batches of data. And that's how I used it. So think of a pipeline as a series of stages connected by channels. And a stage is sort of like not a term that is being used, but I would love for you to think of it as either a single Go routine or a group of Go routines running the same function. It's quite important that a stage consumes and returns the same type. So in the code before, I was showing you that we were having channels of type int, and it's quite important, as you can imagine, that whatever we're sending is whatever we're receiving, or the other way, right? Whatever we're receiving is of the same type. Otherwise, like our structure is not going to work. And just to put it into more simple terms, so imagine channels are sending values to a stage, which de facto are routine or Go routines, and they're being received by other channels. There are three things that happen within Go routines in each stage. They receive via inbound channel, they perform and they produce. They usually produce new values, but sometimes they can just like perform function on their data, modify it, and then they send it downstream. Each stage can actually have any number of inbound and outbound channels, except the first and last stages. Those can only have a single inbound and outbound channel, respectively. And you can think of the very first stage as a source of a producer, and the very last stage as a sink and a consumer. And I want to explain, like I said, this is a talk for beginners. I wrote much more complex code when I was using this and applying this concept, but hopefully you will be able to follow what I'm showing. And I also want to give credit to Samir, who wrote the blog post on pipeline almost 7 years ago. I checked this morning. And to give you an idea about what we're about to do, we will take a slice of integers, we will generate squares of those slices, and we will return it. So like I said, the first thing we're going to do is just convert a list of integers to a channel and emit those integers in a list. So this function generate, it starts a Go routine. And here's, I want to like briefly highlight that we're actually using an anonymous Go routine. If you can see like Go func in turquoise, that also has just open brackets and nothing in the round brackets. That's an anonymous Go routine that will turn that list that we got as an input and return it, return as a channel. And the really important part here, again, is that we're actually going to be closing that channel when all the values have been sent. So, we kind of don't end up with a deadlock of sending things out in the wild. We will actually manage this ourselves. And then the second part is the stage. So this is where we're actually going to be receiving integers from a channel and returning a channel that emits squares of them. So again, we're kind of using the same concept of anonymous Go routine that I didn't highlight in here, but hopefully you can see it in the middle. What it does, it goes through the values that we have in the channel, and then it generates squares. So, just multiplies them by themselves and sends them to this out channel. And the inbound channel is closed at this stage. And we've sent all the values downstream. And now we're also closing this outbound channel as well. So we're returning it at the very end. Now let's put it together. So in the very first two lines, we're actually setting up the pipeline. So we're using that function that we're going to send two numbers. We're going to send 2 and 3. And then the second line is our stage. So out is going to be a channel of our squares. So this main function will also be consuming output as long as there are numbers, and there will be 2 values. And it runs this final stage, right? So it receives values from the channel, the outbound channel, and it prints them until it's closed. So the output of this code would be 4 and 9, which is the square of 2 and 3. And the one cool part that I want to highlight, and I invite you to explore it on your own, is the fact that you can actually make it cooler. You can nest or you can fold those pipelines. So remember, like I said, we can have however many stages we want. It's just a matter of us sequencing and managing and arranging in such a way that, we always have the same types, and each stage performs a single function at a time. So I wanted to show you using that example. Again, don't want to overwhelm you, but since we have the same type for inbound and outbound channels, we can actually compose it however many times we want. And we actually, if we're diligent about it, we can also compose them in different fashion, which is why this method lends itself very well to batch processing, doing very similar types of steps or functions on data, because we can run them as fast as we want to concurrently by using pipelines. So what we're doing here is in the loop, we will be actually generating squares of squares that I showed you before. And I'm doing a little bit of a different output here, but while we're generating that output, we will actually get 16 and 18, which is a square of 4, which is 2 to the power of 4. And we're going to get 18, which is 3 squared, which is 3 to the power of 4. This, I would want to say, like, the magic of pipelines, something that I found really exciting. Definitely, I think an awesome topic for another talk that hopefully I'll give on error handling and what can go wrong if actually something, I think especially when dealing with real data, when we get errors when processing, and how do we handle those. And for that, I actually have a slide for the nerds in the front. Here are some resources that I used, and I think the pipeline link is where, if you're curious, you can read more about it. There are also different use cases or sort of like different approaches to going further with pipelines. And I highly recommend the Rob Bikes talk, Concurrencies and Parallelism. If you also, just like me, are a beginner to Go, or just curious about how and why concurrency was designed in going a certain way. And at this point, actually, I just want to say a huge thank you to everybody for tuning in on a Sunday. Thank you, DevFest DACH, so much for having me. This is my first international talk, which is super special. I hope you learned something. Please definitely stay in touch. Let me know if you have any questions in general. I rate a Medium, and I hope to be writing more about Go. But I'd be happy to take any questions that you may have. Hey, Evgen, I think you're muted. Or maybe it's my...
You're right. So thank you for fixing this. I think this is such a nice talk. Bravo, bravo, bravo. Brilliant talk. I think this is the nice step to introduction in love with language. And I think it's a best step. Just watch a recording or talk to you directly and ask for the introduction steps. I'm also love in Golang, and I'm happy to learn some things. And this is nerd slide was super nice. Thank you.
I'm glad there are more than one nerd on this call. It makes me very happy.
Good. Thank you so much again. So we have this Q&A session. If we have such questions right now in any type, please just type in Twitter or just write an email for us. We will directly show these questions directly to Anna. Or if you have the join our stream, just ask the question in the chat. So we will have some minutes to wait for the questions. Yep. I know that typing questions is hard sometimes, so just wait for another minute or such a way. We could also check the Twitter line. Here we have the also tweets from the first track. I just want to remind that we have two tracks, and you can go to the DevFest online. This is our website where you can check and read more about the speakers that we have today.
Thanks, Patty.
We have a great feedback from the listeners. Okay. One more minute to type or check for the questions. And I will check the timeline for Sunday. That's a big fun day for us. And we will have the next speaker in, I guess, 10 minutes. Less than 10. Yeah, checking for the questions. There is no.
Welcome.
But such amazing support. Thank you, audience.
I think the part that I like about Golang community, and it's too bad I never got to, while I was still in Berlin, I never got to go to any meetups, but in New York, it's a very welcoming, it's a very warm community. So if any of you are traveling, definitely be in touch. Had a great time. Just as I think as a beginner a year ago, meeting people who love Go. And I think that's the most beautiful part about language, just because it's so warming and welcoming.
Yeah, so true. So here also before lockdown times, there was so many meetups and so many events like a hackathon, so small. And there was also the group of travelers who go around Germany or Austria and join the talks. And now we are online, so we can do this from the chair or from the garage like I do, but not so many things happening offline.
Yeah. Well, but I think our love for Golang transcends continent.
Yeah,
So
true,
I
true,
think
true.
that's. I actually have my Golang pin. Yeah, I wanted to wear it today, but it's just like so
Oh,
early.
nice.
So this is the pin that I got at the first meetup. So I keep it
Cool.
on my desk.
Nice. I see so that there is not so many questions right now, but if there is any, we will come back to you and ask for answering them.
For sure. Yeah, feel free to
Thank you
tweet
again.
me. Yes, my
Yeah.
pleasure. Thanks for having me.
Thank you. Ciao, ciao.
Bye.
So we hand over for the like 5 minutes for some break, and we will join again in 5 minutes. So stay in touch. Yeah, hello. Hi, and welcome to track number 2. We are checking our schedule and we are right in the middle before we go for the longer break. So we're getting the lunch, and I know that the feeling before the lunch, the people want to have some faster track and get to know something. And I have some good news that we have next speaker right now here. This is the Shashir, who will talk and continue about our backend stories about the what the heck the generators are and coroutines. So I will invite the Shashir here, and what I really want to hear, how are you doing, Shashir, right now?
Yeah, I'm doing good. First of all, thanks a lot for giving me an opportunity to talk here. Like,
Yeah, you're welcome. Such a nice day to talk to today, and I also want to learn from you.
yeah,
Where are you now? Correctly, right now.
so I'm in my apartment right now in Berlin.
Okay.
Yeah, but yeah, just preparing for this talk and really looking forward for it. Thank you.
Great. You're so welcome. So we will just begin in a moment, and
Yeah, sure.
I want to check that everything is right, and you can now start your talk.
Hello, everyone. I hope you guys are having a great session so far. So I'm here today to talk about generators in Python, and I'm just going to unfold them. Uh, so j- let's just start. But before that, just a quick introduction about me. Like myself, Shishir. I'm working as a software engineer at Snap Engage, and I can be reachable at LinkedIn, GitHub, and Twitter. So let's just start. But before that, I just want to give a quick disclaimer. So this concepts are just from the Python, and I would be using Python codec samples in my talk, and also just bear with me. If you guys know some basics, they are just going to really help us to unfold these things. So let's start with loops. So as we all know, we in our day-to-day activities, we have lots of repetitive collections or the series all around us, and we really need to go over them to get the items and do the things with them. So one way of going or running over them is using loops. So we use while and the for loops for running over this repetitive collections. And if we just see them in a programming example, so what I have done here is I have taken a list of colors. So this color is of my list type, and I'm just iterating over them through an integer indexes. So if you see, I have declared a while loop here, and I'm using a while loop on the colors and then going over them. So now this just works fine. I will just get the list of items, right? But now what if I just change my data type here? Instead of list, I just use a set. So as we all know, set is something where we have a unique data, and here I'm using a set with the while loop. But I think this will also work fine. So let's see what it does. Oops, we got an error here. So it says while, so it looks like while doesn't works with set. So should we use a for over here? So let's look at what this for gives us. So it looks like for just work for us. And are we really going to talk about this in a ongoing series, ongoing talk? So it's not about that. But basically question is why did the for loop work and why didn't the while didn't work for us? So if we look at our data types in Python, so all of the data types in Python which you want to run over a loop are a type of iterators. And when we gave our set to an for loop, it just worked because it just considered the set as an iterator and it went over it. But when we gave it to a while loop, it says a set is not index subscriptable, and the reason behind that is it's an iterable. So if you look at a for loop in Python, it's not actually a for loop. Behind the scenes, it's more than that. Like it's actually, it is taking an iterable object from us and then like returning the element from that iterable object one by one. But again, like if you just see like here, what I'm doing is like I'm just passing a color as a set to my for loop, which is an iterable, and then like I'm printing that color object in my for loop. But like if I just say like it's an iterable, right? Like what does the iterable means? Like what really they are? So it looks like iterables are some kind of objects or the classes which we define, but those classes which implements the specific methods or like methods like getAtom and iter methods built in. So under getAtom and under iter methods are the built-in methods in Python. And if our object implements that, then we say that it's an iterable. So let's try to implement. So let's try to implement our own iterable. But before that, as I told, like list was one of the iterable, set was one of the iterable. So this two types of the two types of data types have their own like implementation of their iterables. So, and that's how like we are also defining our own iterable. And how we have done that is like I'm just declaring a class. In that, like I'm declaring a constructor which takes a value from me and a limit. So what I want to achieve from this is like when I gave a value, I just want to loop over that value until I reach that limit. So that's what I'm doing in my getAtom. So if you look at my getAtom, what I'm doing is like I'm just checking the condition for my index. If my index is greater than 0 and it's less than limit, I just return my value, or else I raise an index error. So this, if I give to my for loop, this works. But I'm not still convinced, or people might not be still convinced like what's really happening here. So before that, like if I just say about like getAtom or iter methods, like how do we implement them? Does really this code needs to be there? Not really. Like we can have like our own implementation inside these methods, but like they should follow some rules. Like getAtom in Python, like built-in getAtom method in Python says that the item should be whatever iterable or the data you are passing, it should be integer subscriptable, which means like it must be following sequence semantics. And my iterator method should return me an object, which is an iterator object. So now, like we know, like we can implement our own custom things in this getAtom and iter method until they follow the rules. But why do we really require this getAtom or iter methods? So when I say like when we pass an iterable to an for loop, our for loop should know like what are the methods available over that iterable so that I get an atom. So those methods are nothing but the getAtom and iter method, because those are the built-in methods, and that's why our iterable needs to follow that protocol. So when we pass an iterable to a for loop, my for loop gives me an iterator object or a getAtom out of it, and my iterator now knows what's the next item over that loop or over that data. So, and that's how I get the atom out of a for loop. But still, like there is, now I just told you iterable, and now I'm just speaking about iterators. So what are those, or how they are related to iterables? So iterators, so when I ask a question to an iterator, what are you iterator? So iterator says me like, I'm an object implementing an iteration protocol. I said, okay. Now, like again, like, and then it told me like, I'm doing a lazy loading and I just do not hold any values upfront. I said, okay. So then I understood like when I get an object, when I pass it to an iteration protocol, I get an iterator out of it. But then what's the iteration protocol? So remember, as I told, like we had an iterable which implements some set of methods. So in the similar way, the iteration protocol is consisting of some built-in methods which needs to be implemented by this object to get an iterator out of it. So this built-in methods are the next method, which returns me the next element. And whenever my data or whenever my collection is exhausted, it should raise some exception, or it should return some error to me. And that error is nothing but a stop iteration error exception. And it has an iter method under iter method over it, which says like, which returns itself. itself means like it returns the object reference again. So that's how the iterators are. Now let's implement those. So last time I implemented repeater using a get item, but this time I want to implement it using an iter method. Now this, if you look at the iter method, it's returning an repeat iterator, which is not defined yet. So, but it takes the value and a limit. Now, when I like implement the repeat iterator, it looks like this. So it takes a value and a limit, but also at the same time, it initializes a counter in the constructor itself. So this counter is now responsible for keeping a track of the next element in the collection of data. Now, if you look at my next next method implementation, it seems fairly clear, like my counter is being checked against the limit. And if my counter is like greater than limit, I'm just saying like I am exhausted out of the list and I will stop there. So this is how the iterators are created. So we had a iterable. We created an iter method inside it, which returns an iterator for that. And that iterator we defined by ourselves. So this is how it looks. But now, if I don't use a for loop, how am I going to, like go over the iterators? So because since we have the next method on our iterator, we can fairly use the next method or we can fairly simply call the next method and we can get the element out of it. So this seems like quite related. So what we are doing here is like I created an object out of my repeater, which I got an iterable out of it. And then by using a repeat underscore iterator, I got an iterator out of it, which I'm putting it my repeat iterator. And when I call the next element, I have the access to the collection now. So that's how it looks. But still, I'm not convinced like how this works with for loop. So if I just show you like how it looks like a for loop, like what we did was we had a repeater, which is an iterable. We passed it to an for loop. Now for loop created an iterator for us using a repeat iter method. And out of that, I'm getting an repeat iterator. Now remember, this iterator has the next method, which knows which element to print. So when I call the next method, now when my for loop calls the next method again and again until it raises an exception, I get the items. So this is how the for loop works in Python. But seriously, are we really talking about like loops here? Not really, but like this will definitely help us to define what generators are or to unfold like the generators here. So what are generators? So generators are just a simple functions, but like instead of returning, so this function, instead of returning the value at the collection of value at once, it returns the value in a series by series way, in a sequence by sequence way. So when I say series, how do those functions do that? So basically what generators do is it takes the collection of items, it uses a next method, which we defined in our iterator. And at the same time, when it returns the next method, it pauses the function. They just suspend them. And when they suspend them, whenever we make again a call to a generator, they know from where to start. It's just like they are not just going to sleep, but like they are just suspending them, so that like whenever I make a next call, it knows from where to pause, because they have that program counter being remembered in their memory. So basically, if you look at the generators, it fairly uses an iterator plus like customized method. Like customized method as in like they are using they are implementing the suspension of the whole function, and also at the same time they are having the access to the next element of the collection. So that is why we call generators as iterators plus yield method. Now just let's talk about like more about yield keyword. So yield is the culprit here who does all the things like suspension, then holding the value, and also at the same time implementing the iteration protocol for us. Just by using a single keyword, like it is doing a multiple things for us. And when I say multiple things, like it is creating an iterator object for us. Also at the same time, it is creating an generator object, which is nothing but the collection of set of data structures, which just knows like where to start the function, where to pause the function. Now, when I pass an iterable to a function, now this function, like in this function, it's not a normal function. Now, how does the function knows like whether I'm a generator function or I'm a normal function? If instead of using a keyword return, if we use the yield keyword there, now my function knows I'm a generator object, and hence that function behaves like a generator and gives us a generator object out of it. So now this generator object, which is an iterator, plus it can execute, suspend, and return the value for us. So that's what generators are. So let's define our own generator. So if you see here, what I have done is like I've created a function which takes two values, like a value and a limit, and I'm just looping over that value, but I'm not returning the value. I'm using a yield value here, which actually holds the value and suspends the function. And after that, like it knows from where should I, resume the things. So when I pass the repeat hello and 3, so at the first time, it just creates the generator object. I'm not starting anything yet. But when I call next over my repeat, it makes a call to a next method. Remember our iterator. And then it gives me a hello back. And also at the same time, it suspends my function. And as I have passed here 3, it will go for the 3 elements. And at the 4th element, it will just raise an exception for me saying that I'm exhausted, I'm out of values. But let's take a deeper look by, like visualizing something so that even we get a better hold over this. So how does this even work? So what I have done here is like I have created a visualizer. So here we have a function, which is a generator. It's the same thing like the previous, which we have like given. But instead of passing 4, I'm just passing 2 because like I don't want to get exhausted of the frames. So here when I just put next, our main so on my right hand side, I have the frames and the objects. So frames is nothing but the call stack, and the objects are the heap areas where my objects are allocated and the memory is being put up. And on my left hand side, I have the 2 indicators. One is like the red indicator indicates like which is the next line to execute, and the green is something like which just tells me where I was previously. So that's how. Let's just go through the line by line what is happening here. So when I defined a repeater, it actually created a function for me, but this function still doesn't know whether I'm a generator function or not because it's just a function definition there. Now when I actually make a repeater call, by passing the values like hello and 2, it created a generator object because this got parsed, and it know that it's a yield there, yield keyword, it interpreted yield keyword, and hence the reason it created a generator instance for us. Now this generator instance have the type of data structures which can hold a value, which has the program counter from where to execute next, and that's how our generator instance will look. Now let's make a call to a print. Now let's analyze what happens. Like when we called next repeat here, if you see, like I just passed 2 and hello to this, it came to while loop, the condition is okay, so it will go to the yield now. Now when it came to the yield, the magic happens here. So it returns the value, but if you see, it doesn't goes to the 4th line, it just suspends between 3 and 4. Now how it is getting suspended is like it just remembers the next program counter, which is 4, and it just puts itself on the hold, like the call stack is being removed, like popped up, and it returns the value. So we see like we got hello, but at the next time, what happens is like when I make a next call again, it doesn't goes to the while, because like now my program counter knows from where to resume. So it knows like I need to resume from the line between 3 and 4. So it resumes from 4, it decreases the limit. If you see that the limit will get decreased now 1, and it will again go to the loop. And once it comes here, like it will like again, like the normal checking will happen, the normal value will return, and again it will push the program counter as 4, sorry. So this happens, okay, and we get the value. But now since we resume from it, our integer got decremented to 0, and now we are kicked out of a while loop. But once we get kicked out of a while loop, this whole function will return the none type to a generator, and once the generator gets the none type, it will raise an exception for us, because it says I'm just exhausted, I got kicked out of a loop, and I don't have any value, so I need to raise the exception there. So we should be getting a stop iteration exception, and that's how we got it. Okay, so this is all like generators like working in background. But my question is like, where do we really use this, right? So let's consider a problem wherein like we are giving a large list of numbers, and from this list of numbers, we need to go to every number and see whether if it is an even, we need to calculate the square of it, and we need to push it to another list. So problem seems simple, right? Like we can just do a traditional approach, use a for loop, use a list, put all the numbers into that list and return those lists. This is fine up till like we have really small numbers. But what if like I really pass a large number? What happens if I pass this number? Surely I'm going to get the output, right? But I don't want this outcome as well. So let's look at like, if we just want to avoid this, let's look at how a generator approach will work or look like. So here what we did is like we just yielded a number. Instead of returning it, we just yielded it. And when we yield it, remember a call stack, it will just get resumed there. It will just get paused and it will return the number. But on the next call only, it will move to the second number. And then after the next call, it will move to the third number. In such a way, it will just move. We are just not getting the whole like list at one single time. We are just incrementing it in a slowly way, like in a lazy fashion. So that was generator says. So when I did a profiling over these two approaches, I got up with these numbers, like which seems really like which makes sense me to, and which told me like why to use generator. So if you look at our memory usage for the list approach, it was like around 2000 megabytes, and for the generator approach, it was like just 2 MB. And the reason behind it was because like we are just not getting the whole list at one single time. We are just getting one element and a next pointer to it. So just think of this linked list, right? Like how we have, like we just get to the first node, and from first node we need know where to go to the second node. But second node is not on a memory. It's just like it's just making a node on the fly, and we are just going to a second node. So this is how like the generator works in real. So I just don't. So basically, from here, where to go next? So there are a lot of things going in the Python community nowadays regarding the generators and coroutines. So yield keyword is just not taking about input. It's about like it's just not about giving output, but it also takes the input. So when it takes the input, we called it as a coroutine. And since like Python is really like it just one, it says like we need to get rid of number of lines. So that's where like instead of writing our own generators and coroutines, like implementing them using a yield or this keyword, we use async and await. By just defining a single line, you just declare a generator or a coroutine. So that's like you can go from here, and this would be really a good foundation for you to start looking into like what are generators or coroutines and how can you utilize them. So yeah, I think that's it for today. Like, just let me know like if you have any questions. I think it's me. Oh, okay.
Thank you again for the talk. And this is really nice introduction and such a nice journey and beginning to the generators in Python. So what we're gonna do next? We have some minutes to wait for the questions, and then we will try to answer them. If not, we will gather the questions and send them directly to you.
Sure.
Yeah, I need to mute myself again because my home automation turned on the ventilation system and it's pretty loud.
Okay.
Garage. Okay, look forward for the feedback or any questions. Oh, we got one. Do you know if there any concept exists to other programming languages, like the generators and other programming languages?
So yeah, like I'm not quite sure about like the number of languages, but there are surely, like in Java, generators are coming into picture. There are already coroutines in like Java, and Go is actually built upon Go routines. I just like Anna like mentioned right in the previous talk. So lot of like things are going around these generators and coroutines in the other languages as well, because like they just see the power, like like of not getting the data at once, but like incrementing them over a period of time. So yeah, I hope that I answered.
Yep.
Yeah.
Yeah, nice feedback from the audience. Okay, we still have time, so please write the questions. Okay, let's check again the Twitter or any other sources. Some more time for questions. Yes. More nice feedbacks, but no questions so far. So I think that people need to get some time and then we have maybe more questions, or we just need to rewatch the presentation and go over the slides.
Yeah, that's true. Like I think like most of us are hungry now.
Yeah, true. So let's
Yeah.
wait 1 minute,
Good.
and then if there is no more curious topics, go for the lunch.
Okay.
Okay, so I see that there is no more questions. I thank you again. I thank your audience, and
Yeah.
I believe
And
we will meet again.
yeah, and thanks a lot for like giving this opportunity to talk here. And I'm really looking forward to also like talk about coroutines and talk about this stuff more, like because there is a lot of happening in the Python communities around these things. So thank you,
Yeah,
Dave. Yeah.
you're right. Great.
Yeah.
Okay, see you soon. So,
Yeah.
ciao, ciao.
Bye. Bye.
Okay, we are heading back to the middle timeline for our schedule, and then we have the next bunch of the good talks. And what we're gonna do right now, I will check the time. So we agreed on that we will start at 1 p.m. 45 minutes with the next talk. So be there, be here in 1 or 2 minutes before the 2:15, and we will welcome you here. Stay in touch. Hello. So welcome back on the track 2. So we have really nice speakers upwards, and I'm really excited to hear more about the backends, DevOps, and cloud stories. What we're gonna do next, we will check that everything is fine and try to get up for the next speaker. And the next speaker here is the Guillaume Lecoeur, who is also our GDE, so who is a developer expert in the Google communities, and he is worked as a cloud architect, Java developer for more than 15 years, and for any thing that related to the cloud, Python or Go or any cloud certification, you can ask him or just join for the next topic that we here have. This is the security in serverless compute on GCP. Take over the control of infrastructure. So welcome, Guillaume.
Thank you. Hi, everyone.
Yeah, hi. So I hear you really well. Where are you now? I'm looking for the interesting topic that you are prepared, but I'm interested also where you are right now.
Yeah, okay.
Okay. So let's then start with our short.
Okay, hi everyone. I'm Guillaume Lecoeur, and yes, I'm a Google developer expert on Google Cloud. And today I will talk to you about how to take over the control of the serverless security. Because serverless is a new trend to develop application in the web, and it's great to have some best practice in security. I'm also a cloud architect at Sphere. Sphere is a consultancy company in France focused on Google Cloud. But before going deeper into security in serverless, I would like to define more precisely what's serverless. Serverless, you can see it in two different manners, in fact. You can see the serverless as an operational model, and you can see this as you have nothing to manage, no server to manage, no network to manage. All the firewalls, the routing, the server management and patching is performed by the cloud provider, and you don't care about this part. In addition, you pay only when you use the service, and you don't have to provision and to deprovision the servers. All this part is also managed by the cloud provider, and you pay only when your service runs, and when you have no traffic, you pay nothing. That's for the operational part. You have also another point of view for the serverless. It's the developer point of view. In fact, a developer wants to develop a service, a microservices, because the microservice is the fashion today, and these services react to events. It could be cloud events or also external events, such as HTTPS requests. And from the developer point of view, what is important is to deploy the service on a server, on a platform, on Azure, on AWS, on Google Cloud, on premise. It's not the concern of the developer. The developer wants something portable to deploy the service and to bring the value to the customers, to the users, and then to achieve its work. So you have two points of view for serverless, and in this talk, the point of view is more about the operational model than the programming model. And when you talk about security in serverless compute, what the serverless compute on Google Cloud? In fact, we have three main products in serverless compute, because in serverless, you have a lot of products in serverless on Google Cloud, such as BigQuery, Dataflow, and so on. But in this talk, I will focus on three services, which are Cloud Function. Cloud Function is a very simple service. In fact, you write a function, a small piece of code, and then you ship it in the cloud. Google Cloud gets the code, compile it, package it, and then deploy it somewhere on servers. I don't know. It's serverless. I don't know where are the servers. It's not my concern, but you can run only one piece of code when you use Cloud Function. If you want to serve more endpoints and more URL paths, it's better to have web servers and then to serve all these paths. And like this, you can use Cloud Run. With Cloud Run, you package your web server in a container, and then you ship your container, and the container is deployed also on servers, on cluster, I don't know where. And the container is served on internet. But it's more defined for the backends because it's more API oriented. If you don't want to manage a container, if you want to only provide your source of your web server, you can use App Engine. App Engine, it's the oldest service of Google Cloud, and you send only your sources, and the container is built by Google Cloud, and then deploy also like Cloud Run, but not on Cloud Run infrastructure, on App Engine infrastructure. And App Engine is the oldest services, deployed in 2008, so very early, 2 years before the beginning of AWS, and it's one of the oldest services, serverless services on public cloud provider today. So I will focus only on these three services. Why? Because you have your code that you can deploy on the platform. And when you have some question from security team, your manager, sometimes your customer, about the security, you have to answer them correctly. And some question can be naive, and you have to answer some questions such as, how do you manage the patching? And how to patch the servers, because you don't have the servers. It's difficult to answer these kind of questions. How do you manage the network? And typically, how to use static IP to access other services, or how to make your service private and not reachable from the internet. Because you don't manage the server, you don't manage the network, it could be tricky to do this and to answer this kind of question, or requirements if it's a customer. And how to ensure the high availability of your service. How do you control the access? Who can access, and how to be sure that anybody can access the service. And of course, if you have an attack, how to mitigate this attack, such as DDoS attacks. So all question, not really easy to answer, and I will provide you some tips and schema to achieve this kind of answers to this. So how to take over the control. First, how to patch the server. Of course, it's serverless. You don't manage the servers, and you have no server patching to achieve. This part is very easy. But when you create an application, you will write your code, and this code has some dependencies. And with Cloud Function and App Engine, you bring only your code and the dependencies. And sometimes in the dependencies, or even in your code, you have some security issues that you have to fix. And when you use Cloud Run, of course, you bring your code and your dependencies, but also the container with the base image, and with maybe some system dependencies that you have installed on this base image, and you have to patch all this container because also sometimes you have some security issues in the base image on the or the system dependencies. For this, so you don't have nothing to do. You don't have to patch the servers, but you have to patch your application and your runtime environments, in fact. A best practice, for example, is to deploy every week or every month the same code, even if you have no change in the code, and to repackage with the latest version of the dependencies or of the base image for the containers, to run your unit test or your integration test to be sure that the code continues to work as expected, and then to redeploy regularly with the latest version of the dependencies or the containers to be sure to be up to date with the latest patch in your application. The next points are about the network management, because sometimes you have some serverless apps on your side, Cloud Function, Cloud Run, or App Engine, and you need to reach only internal services, such as Compute Engine or Compute Engine, or maybe some products in Google Cloud Memory Store, which is a release managed on Google Cloud, can be accessed only with private IP. And how to do this with serverless product? Because with serverless, I repeat, you don't manage the server and the network. Same thing when you have an external platform to reach, for example, your on-prem environments, and you need to reach it with private IP through a VPN or an interconnect. The solution for this, it's an important tool or feature on the serverless world, is named Serverless VPC Connector. In fact, this connector is a bridge between your serverless world, where you manage nothing, and your VPC, your virtual private cloud, where you can route the traffic from the serverless world to your VPC, and then you are in your VPC and you manage what you want in it. You can access internal resources connected to your VPC. You can enforce some firewall rules, and then you can route the traffic. For example, you can route the traffic from the VPC to a VPN to reach your on-premise environments. At the opposite, sometimes you want to go out with specific IP because you have a service outside that trusts maybe a login and password, but also the source IP of the request. It was the case in one of my company where we had a FTP server, and to connect it, we need to have the login, the password, and to confirm the correct source IP. And because it's serverless, all the products, when they go to internet, use shared IPs on Google Cloud. And in fact, any solution, any Cloud Function, any App Engine from my project or from the project of the others on the world can use the same IP to go on internet. So you can't trust the platform IPs. To solve this, here again, you need to use the serverless VPC connector, and then you have to route the traffic from your serverless world to your VPC, and then to plug on your VPC, you plug a cloud router to route the traffic to a cloud NAT, and in cloud NAT, you can reserve some IP, the IP dedicated to you, to your platform, and then you can trust them because you are the only one to use them to reach your external platform in this case. However, this solution is only available on Cloud Function and Cloud Run because, as I said before, App Engine is an old service and there is some legacy on the environments, and it's not possible to have the same feature in the serverless world. Okay, now we can go outside with a static IP, but sometimes we can want also to discard any private IP to reach public IP to reach our service, because the service is only internal. You don't have to access or to be accessed from the external, such as background process, because you have some sensitive data processed by the application. You don't want that external call come to your serverless apps. And also to reduce the attack surface, because if you have less service exposed on internet, of course you have less attacks, or you don't let the capacity of bad actors to attack you. With Cloud Run and Cloud Function, you have the capacity to control the ingress and where the ingress comes from. With App Engine, so it's also a quite old service, you have something like firewall rules. It's not exactly the same process, but yeah, you can do stuff with App Engine, but here it's really focused for Cloud Function and Cloud Run. The ingress control say, I accept only the traffic coming from my VPC. And nowhere, if the traffic comes from the public IP, the traffic will be rejected, and the only traffic accepted by the platform is coming from my VPC, not the VPC from the other customers, my VPC in my project. So now, if you want to call, for example, a Cloud Run service from a Cloud function, you need to come from the VPC. And for this, of course, you use the serverless VPC connector to come from the serverless world to go to the VPC, and then you are in the VPC, you can reach a private serverless product. Of course, because you have also other resources on your VPC, for example, Compute Engine or Kubernetes Engine, you can access to the serverless apps from these products. And also, if you have an external platform, your on-prem environments, and you are connected to your VPC through a VPN or an interconnect, of course, it's possible also to reach your serverless apps through this private link, because you land in your VPC, and then you the next hop is your serverless world. That's for the ingress control. You can set the ingress control as internal, but you can also say, I accept the internal traffic and the traffic coming from the cloud load balancing. And like this, you can add a load balancer, and the traffic will be able to come from a load balancer and go to the serverless apps. And you can expose, for example, a public IP in front of your serverless apps. So your serverless apps are still public, but not directly reachable from the internet to the serverless apps. You need to go to the serverless, to the load balancer to reach it. Else, your traffic is discarded and rejected. And of course, you can also use the traffic coming from your private cloud to the cloud load balancing, and have, for example, an internal load balancer if you want, and then to route the traffic to your serverless app. Next point about the high availability. Just before going deeper, just to remember, when you deploy code on serverless products, by default, your deployment is high available at regional scale. What means one region on GCP have at least 3 zones. If you want a zone is a data center, and then to be highly available for about the region, you have to deploy at least in each zone in a region to be high available. So by default, when you use Cloud Run, App Engine, or Cloud Function, you are high available at regional scale. But if you want to be high available at global scale, you need to use an HTTP global HTTPS load balancer, and to have an Anycast IP to broadcast. In fact, to have an Anycast IP which is deployed and understood in any part of the world. Then you can deploy multiple backends. For example, Cloud Run, you can deploy it on each region in the world. And you can also deploy, for example, App Engine. App Engine is only mono region. You can deploy it in multiple regions in the same project, but with Cloud Function, you can do this. And what is very great with an HTTPS load balancer, in fact, the traffic is routed to the closest location to the users. That means if I'm in Australia, for example, if I request my Cloud Run service, I will go to the Australia location. And if I request, for example, the Cloud Function, there is no Cloud Function in Australia, and the HTTPS load balancer will route it to the closest location. I don't know what is the closest location from Australia, the US West Coast, or the Europe. I don't know, but the load balancer knows this and routes the traffic to the closest location. And of course, if, for example, you have a major outage in Australia and you can't access to the Australia region because you have a major outage, the traffic is routed to the other available region, and that is very great to have an high availability at global scale. Just a warning on this, most of the time, the processing part is not the problem when you go global to deploy your application. Most of the time, it's the data. The data is a problem to have a global database and accessible from anywhere in the world. And sometimes it's the part the most difficult, not the processing. But it's at least great to have some solution like this to be global. So now, how to access to your service? In fact, when you deploy something on Cloud Function or Cloud Run, your service is deployed behind Google Frontend. Google Frontend is a layer responsible of many things. One of the things is to host the TLS certificate to have a SSL connection to your service. But also you can ask Google Frontend to filter the traffic and to accept only the valid traffic. If you deploy a Cloud Function and a Cloud Run in private mode, that means you require an authenticated connection to the service, authenticated and authorized connection to the service. Google Frontend will perform three things. The first one is to validate the token. Token is expired, the token is valid, the signature is valid, so the token must be valid. The second thing is the identity must be known. And the third thing is the identity is known, but the identity must be authorized on the service. And if these three actions are not valid, the request is discarded. What means also if you have an attack, if you have a DDoS attack, for example, all the traffic, all the bad traffic is filtered by Google Frontend, and you pay nothing because it's on Google part, and you pay only for the valid requests that come from Google Frontend to your Cloud Function or to your Cloud Run. And like this, you pay only the real job that you do, and all the bad traffic is not for you, it's for Google. But sometimes this pattern has a problem because you need to provide an OAuth2 token in the header of your request, and some platform can't provide this kind of token because of there's legacy, because technically they can't. So for this, you can update and improve your extend your capacity of authentication thanks to API Gateway or Cloud Endpoints. In fact, API Gateway, it's the serverless product of Cloud Endpoints. Cloud Endpoint, you have to manage it by yourself, and API Gateway, it's the serverless mode of Cloud Endpoints. And thanks to API Gateway or Cloud Endpoints, you can add the API keys and the Firebase auth authentication capacity, and then to access the traffic from this kind of authentication, and use the service account, the identity, in fact, of API Gateway or Cloud Endpoints to generate an OAuth2 token, to put it in the header, and then to forward the request to your serverless product. And in addition, with API Gateway and Cloud Endpoint, when you use API keys, you can add quotas and rate limits on your paths, on your endpoints, to be sure that all the usage are fair on your services. Then the last one is the DDoS attacks. I already talked about Google Frontend, which is a Google layer in front of all services. I mean Google services, not Google Cloud services. It's really a Google services that protects also Gmail, YouTube, and other platforms such as Maps and so on, and also protect your service in the same manner, and already prevent some attacks of layer 3, such as partial IP or incorrect IP format and so on. You have a lot of traffic already discarded by default thanks to Google Frontend. But you can also add a load balancer in front of your service, and on the global HTTPS load balancer, you can add Cloud Armor. Cloud Armor, it's a customizable WAF, web application firewall, and you can add some rules and policies to filter, to accept some IPs or to reject some IPs, to reject IPs coming from some parts of the world. So you can add a lot of policies, and it could be very efficient to mitigate your attacks and the location of your attacks if you know them. And I recommend you to have a look on it because it's a very powerful tool for this. So just to conclude, the security is not very easy with serverless because it's not the same paradigm as before, because serverless is a new paradigm. You have no server, no network to manage, and thus the security is quite different as the legacy world, but it's important. And I read somewhere this sentence, it's not from me, it's from someone who say, if the security goes well, your business will follow. And I'm sure you have in your mind a lot of example of company with great product, very promising, and because there were some security issues, the products crash or have difficulties to continue to live because you have the product have lost the confidence and the trust of the users, and you can continue to use this if you don't trust the service. So think about the security is very important. Sometimes it's boring. I know it's not very fun to work on security, but it's very important when you have a product in production, and it's important to focus on this. That's all for me. I would like to thank you for your attention and to be here. If you want to follow me, you can follow me on Twitter. I will publish the slides. If you want to have access to the slides, I will publish them on Twitter. Also write some articles on Medium about security and serverless, because it's the two topics that I love on Google Cloud. And if you want to ask me a question on Twitter, on Medium, on LinkedIn, or where you want, don't hesitate to reach me. I don't know if you have time for question now, but so if you have a question, I will be happy to answer you now. Else, it's for later. Thank you very much.
Thank you very much too. Thank you for the such nice slide over the 6 main serverless security topics that are really in top right now. So I'm really excited for follow the slide back and get into contact with you. Also, the really nice thing that you mentioned about the new features that Google Cloud Platform has. So about the web firewall and the OWASP top 10 securities. So really nice that we have all things together in one talk. I believe now we can check for feedback and check for questions. And I'm going to do this. If there is some, I will read it for you and we will start the questions. But for now, I have one small thing. What are the sources for information that you use for gathering the security topic over the Google Cloud Platform?
There is no security topic exactly for Google Cloud Platform, and sometimes it's a problem. I'm following the news on the platform, and some new release are focused on the security, and that's why I added in my package and my bag. But yes, you have to check what is new, and you have also to deploy on real production your services and to ask yourself, I would like to do this. Okay, I will go deeper in the documentation and search which feature can help me to answer this. And it's not really easy at the end, and that's why I like to perform this talk, because you have a summary of all what can you do on serverless environment on Google Cloud, a summary of what you do, because there's a full section on Google Cloud documentation for this.
Yeah, right, exactly. So I'm also trying to get more and more on the news for the security in the serverless world. But yeah, I see that the nice approach is just to follow the news and use the practical approach. Okay, questions.
Yeah, for instance, following the news, it's quite time consuming. And so I'm a GDE, I passionate by Google Cloud, and I follow this every day. But when you are just a developer, a practitioner, focus on Google Cloud, but also on other platforms, it's difficult to follow all the news because Azure, AWS, Google Cloud has a lot of release every day, and it's difficult to follow. And yeah, sometimes it's difficult to have the good news at the right time.
You're right. So as I see, I just checked the main channels for our questions. There is not so many questions or feedbacks because we just I think that we need to wait a bit, and if there is some, we will contact you directly and direct all the questions directly to you, collect them, and then you can answer them. So for the next 1 or 2 minutes, we will check again if there is something, and then I will read it them. But so far, everything is like silent, and maybe we will see the questions upwards in a minute.
Yeah.
Just checking again. Okay, so no questions
Okay.
for me as I see, and no questions for all the channels. But okay, I think this is the nice wrap up for the security and the nice start of the second track. So I wish you a really good day, and I hope to see you again.
Yeah, I hope also, maybe in person.
Yeah, see you again. Ciao, ciao.
Have a good day. Bye.
Ciao. Okay, we are heading further, and here is the, I think, again, a 8-minute break for anything that we are planning so far is the next cloud topic that we'll cover in the next 40 minutes. So please stay with us, stay connected. See you. Boom. So we are here again, and this is super nice opportunity to us for invite such a nice speaker that I really follow a long time and really want to hear personally today. This is the Chris, and he will talk about the cloud native analytics infrastructure. So he is mainly about the data engineering and data analysis. So in many cases, you need to follow this for 30 to 40 minutes talk and get to know about what we have in data analytics and data infrastructure in our cloud native world. So huge round of applause and welcome, Chris.
Hi there. Thank you very much for having me.
Yeah, you're welcome. I really enjoyed the previous talks from you and want to know more today. So looking forward for
Awesome.
the talk.
Thank you very much. Yeah, I'm quite excited too.
Good. So I don't want to stop the good flow today, and let's start the talk. So
let's go. All right. Well, thank you everyone for having me. I'm quite excited to give this talk. Today I'm going to be talking about cloud native analytics infrastructure. And what I really want to do is I want to give you an overview of all the options and tools that are out there and kind of drill it down to what do you actually need? What are the decisions you should make when thinking about, hey, I need to analyze data. I need to collect data. I need to look at data. I want to run reports. What is it that you actually need to collect, process, and then visualize maybe later on data from your applications, from your users, really from a wide case of background and range of use cases. But first, so hi, I'm Chris. I work for Do International, a large cloud and Google Cloud partner. I'm a cloud architect there, and you can reach me at chris@doitintl.com. But without further ado, let's jump right in. So the moment you start thinking about data analytics in the Google Cloud, you might be going to this page, the product overview page of Google Cloud, and see what are they having there. Well, they have a bunch of products, and this is just the highlights, right? This is just a top line. You can drill down into each of these and see sub-products and sub-features and a whole, like an endless catalog of stuff that helps you to do something with data. What we want to do, we want to break it down to 3 simple layers that you should think about. And then for each, I'm going to help you make a decision what you actually need in this layer. So let's take a look at the layers that we're talking about. We're going to be talking about database. That's kind of the central thing for all things data analytics, right? You need a place where you can load data into and you can use to get data out again. Then processing. We're going to see that there are a couple of options for processing and a couple of use cases that kind of drive these processing demands. And then lastly, scheduling, because you don't want to put a Post-it note on your screen, hey, remember to calculate this report Monday morning. You want to have something automated that does all these steps that are maybe required to prepare data for analytics and run these in an automated fashion, in a workflow, on a schedule, whatever might suit your use case. And we're going to look at a couple of options there. So let's jump right in. Database. When we're talking about databases, the first thing I have to say, analytics will require an SQL database. Even though there are a lot of tools that you can put on top of the SQL database to you not having to write SQL to analyze data, the language, the universal language for pulling data, working with data, etc., is still SQL. So when we're picking a database, it's really going to be an SQL database. And now, again, we have plenty of options, right? There are like the very well-known and more transactional databases like a PostgreSQL or MySQL. These are databases that are focused for application use cases. If you're coming from an application background, you might be very familiar with these kinds of databases. And to be honest, they're really good at data analytics. They have a lot of positive things that they can do really well. But they also have some limitations, especially when we're talking about getting bigger and having a database that is not just on one server, but maybe can handle a lot of data on a lot of servers. And to shortcut this conversation a little bit, if you are on the Google Cloud and you need a place to put analytics data and to do analytics, it is most likely going to be BigQuery. This is one of Google's earliest products in the Google Cloud. And it has a couple of things that make it really the database for analytics, not just in the Google Cloud, but probably across all clouds. So let's look at what this is. The first thing is serverless. We just had a really nice talk about serverless. And there are a lot of benefits of using serverless services. With BigQuery and data analytics, this primarily means zero maintenance. You don't have to worry about provisioning compute, about updating servers, patching servers, scaling up more resources, scaling down resources. All of this stuff is managed by Google for you. It's really, especially when you're starting small, the place to be, because you don't want to have another DevOps setup just for running analytics, right? The second piece is standard SQL. A lot of databases have their own fancy kind of syntax for SQL. And this can make it less portable. There are slight differences in the flavor, how specific commands are run, how strings are concatenated, and all that kind of stuff. BigQuery is using the ANSI standard SQL, so like a standardized format of SQL that works across most databases and will be a safe standard going forward. But still, this vanilla SQL has plenty of power, as we're going to see going forward. BigQuery really is a full power workhorse for all kinds of analytics use cases. In fact, and that's the next point, it can scale to petabytes if you need it to. But you might be saying, well, I don't have petabytes. It doesn't really matter. It works just as well for megabytes as well. That's the beauty of BigQuery. It's serverless, right? It scales from nothing to a real lot in seconds, and you don't have to worry about how it does it. You just have to bring your data and get going. It has a powerful API. While a lot of more traditional databases require you to manage connections, create a connection, and then send SQL strings over that connection, committing them in transactions, etc. With BigQuery, you can do a lot of these operations via an API. Again, if you're coming from an application background, this is a really familiar way of working with services, right? Using a REST or an RPC API. And of course, you have a really nice UI, but you also have a really powerful CLI. So BigQuery kind of works very much like a cloud service and less of an instance-based database. And lastly, BigQuery is cheap. You really only pay for what you use. And that means, for example, if you store data, the moment you start, like the second to be precise, the second you start storing data in BigQuery, you will be charged for the storage. The storage pricing is actually compatible with the cheapest storage you can get on the cloud. For example, Google Cloud Storage or S3, right? Really compatible long-term storage pricing is available in BigQuery. And then when you actually run a query to look at the data, you also only pay for the query when it's running, like the amount of data that's pulled into the query. The moment the query stops, the query engine that Google has ready in BigQuery is not charged to you at all anymore. So these pros together kind of give you a database or an analytics solution that scales not linearly with your data, so with your usage, with your business success. It kind of just, I don't want to say linear, but it's scale much slower, the overhead that you have when running this. So BigQuery, I'm sorry that I can't give you like a wide list of options here, but it wouldn't be fair. BigQuery is the place to go when you start with analytics, and probably also the place where you want to stay long-term when you get a lot of data and have a very heavy lifting, heavy use cases running in your analytical database. There's another really nice thing about BigQuery. There's a couple of ways in how you can get data into the database. The first one is you can load batches of data from files into BigQuery tables for free. And that is, I mean, it's not a big thing when you're just loading small CSVs, right? But when you start loading huge amounts of data, I'm talking terabytes of data, you are never going to be charged for the load operation itself. This is all on Google. Even if it's a heavy load and you have to uncompress large amounts of files, not just one, but many files, Google will not charge you for this. This is always going to be free. And by the way, it's also free to get data out again. The export jobs are just as free. The other way to get data in is to write individual records directly into BigQuery tables via REST RPC calls. Again, traditional databases would require you to open a connection, have an insert statement like in SQL string, that kind of where you have the data in and then write it this way. With BigQuery, you can do a REST or an RPC call right into a table. Extremely powerful. This is something that's extremely easy to implement in an application, just like writing a log, basically. There are, additionally, as a third option, there are a couple of fully managed BigQuery transfer services for common data sources. So for example, there's a predefined service to load files from Google Cloud Storage on a schedule. There's also a service to load data from the Google Play Store, for example, the reporting API right into your BigQuery. It's just the same for YouTube, Google Ads, and a couple of other sources. And then lastly, this is kind of a hack, a trick. I might not want to rely on this for large-scale applications, but if you want to get going quickly, you can actually stream application logs right into BigQuery. So if you're having a service running on Google Cloud and you're writing something to stand it out, it's going to go into the into the general Google Cloud logs, formerly known as Stackdriver logs. And from there, you can create a filter. Oh, just these kind of logs I want to have streamed into a table in BigQuery. This is extremely powerful and can make it super easy because you might already have logs for typical activities that are happening in your application. Getting these into an analytical database like this is super easy and super straightforward. So a couple more reasons why you might want to think about BigQuery from the very beginning. Next, let's look at processing. We have a database. Now we want to do something with data. And there are really two scenarios when you have to think about processing. The first one is you have data that does not fit into your database right away. That is one scenario where you typically think of, you have a CSV that's mail formed and you have to kind of change it before you can actually load it. Or you have some weird JSON data that doesn't fit like that into a BigQuery table. BigQuery is quite flexible of what it can load, but there are limits to it. And then you need some processing. Also, you might want to run processing within your database. You have data already in the database, and now you want to transform it, you want to aggregate it, you want to run some machine learning on it, you want to run some advanced, like kind of transform data that's in there that kind of has a weird format, you want to extract data out of string fields and that kind of stuff. That's also another use case. Let's look at the kind of tooling you could do for that. The first one, and that's, it's kind of an obvious one, SQL. It has a lot of benefits of running as much as possible in SQL because it runs in the database, it scales, and it's optimized for this kind of stuff as well already. You can use any kind of generic compute. Obviously, you can load data either from the database or from outside the database and then back into the database from kind of as simple as a cloud function, as we just learned, to something as complicated as a Kubernetes workload, or even something on-prem. It doesn't really matter there. This is also an option for doing some processing. And lastly, data flow, kind of the gold standard for data processing in the Google Cloud. It is super powerful, extremely scalable, and extremely flexible at the same time. Let's dive into these three a little more and see when to use what and when not to use something. Let's start with structured query language, SQL. Again, it's powerful, scalable, and optimized, and is optimized for the processing environment that you're in. It's in your database. Your database is meant for this. Very often, I see, especially application developers, they are maybe not too familiar with the analytical functionalities of SQL. And they see a problem that goes a little bit beyond a sum or an average or something like that. And they immediately jump, okay, let's get data out. Let's write a little script. Let's write some Python. Let's write something more advanced and run it in a container. And people think twice if you really have to do this. SQL is extremely powerful. And it has a huge benefit of kind of staying in the language or in the ecosystem that you're already using, a database, for this kinds of processing. SQL has amazing features, like, of course, all the kinds of aggregations, statistical calculations, window function, all this kind of awesomeness. But it can also do geographical functions. Like BigQuery, for example, has a whole suite of data functions to calculate distances between geopoints or calculate the size of areas, check if areas overlap, and all that kind of stuff. There's functions dedicated for networking usage, right? You have a full URL and you want to extract the host name, you want to extract the port, the protocol. There are pre-built functions to do that in just a single line, really straightforward. And then there are other SQL standards that I didn't list here, but for example, in BigQuery, you can run ML use cases in SQL in the database. Extremely powerful. So really think about SQL a little more when you're thinking about processing data. So do use it. as long as you can, really. And you should use it, try to use it as much as possible, because you have it available in your stack already the moment you're starting using a database. Don't use it. Well, that's what I mentioned earlier, when your data needs transformation before loading it to the database. So if you have a file that cannot be loaded to a database, obviously you can't run SQL on it. So in these scenarios, you will need something else. And obviously, also, if you're trying to do some extremely fancy, that SQL is just not meant for, right? There are scenarios where SQL is kind of overpowered and not the right tool, and you need something that's a little more flexible, that can do other stuff, like super fancy machine learning with super detailed configurations, for example, or anything that doesn't kind of fit in the kind of table way of thinking that SQL has. So structured query language, like, you should be your first go-to for all kinds of processes you need in data analytics. The second thing I mentioned, generic compute. This can be anything from a cloud function, cloud run, like we just heard, Kubernetes, Google App Engine, or just any VM. You have full control and flexibility of how you do stuff in there. You can bring your own language, you can bring your own kind of compute power, you can bring your specialized hardware like GPUs, but you have to implement scaling and optimization yourself. Like, you might be thinking, well, a cloud function, I can invoke a lot of cloud functions at the same time. Yes, but typically when you load data, for example, from a file, you can't kind of you're gonna have a hard time breaking up that file in generic compute. You always need to load a whole file and then process on that file, and then maybe load the results into a database. But what if your file size grows because your business grows, your user base grows? All of a sudden you have much more transactions, and the daily transaction CSV all of a sudden get huge, or it's not just one CSV anymore, but multiple ones. It's going to get more and more difficult running these on generic compute resources. So do use it for simple and small tasks and for orchestration tasks. When you don't only basically tell an API, hey, service X, here's my file in service B, please load that file. That's where generic compute can be really helpful and useful. But the moment where you load the data and do something on it, start to get careful. Don't use it for intensive processing, for large amounts of data, and when you want to avoid technical debt. Honestly, I've seen that a lot, where all of a sudden your generic compute solution for a data problem kind of became technical debt because you've been using it too long and the data grew, and you kind of started gluing hot fixes on it and never really got to a stable solution. And then lastly, again, a little bit of the gold standard, the biggest solution that Google has to offer for powerful and scalable data pipelines, Cloud Data Flow. It's a managed service, so it's not entirely serverless. Google will manage instances in the background for you, and you actually have quite a bit of control over these instances, for example, networking control, but also the kinds of instances that are running in this service. But Google will make sure to run like the latest service software on this. They will take care of scaling machines up when your workload increases. They will scale it down, of course, as well, etc. So it is inherently a managed service. Cloud Data Flow is actually just a runner for an open source framework called Apache Beam. So when you write a pipeline in Cloud Data Flow, you write it with the SDK of Apache Beam. And when you say, okay, my pipeline is ready, please run it now, you submit it to Cloud Data Flow. If you ever decide, actually, you know what, I don't want to use Cloud Data Flow anymore, or I have this specific workflow that for some regulations reasons, I have to run this on-prem, I can't bring this to the cloud, you can also have other runners, like, for example, Apache Flink or Apache Spark, and run those wherever you like with the same code written in Apache Beam. Writing code for Apache Beam, there are 3 SDKs available at the moment: Java, Python, and Go. It is a little bit like with Spark, though. It's inherently written in Java. So the most straightforward development experience you will always have in Java. But I have had great success with Python as well, personally. In general, though, if you have the option to go with Java, I would still probably recommend going with Java. So when to use this? Do use it for heavy processing and large amounts of data. Do not use it for quick one-off solutions. Honestly, it's not going to make sense. Data flow, and Apache Beam especially, is a big system. It has a lot of concepts that you have to think about, that you have to learn. The way data flows through such a pipeline, it's a little special. You have to have a couple of specialists, or at least a little bit of time, to understand the specialities of Apache Beam before you really are effective in it. But once you are effective, it is really the ultimate workhorse for all kinds of data analytics in the Google Cloud. So there we have 3 options for processing data: structured query language, generic compute, or cloud data flow. Let's take a look at the next piece: scheduling. We have seen the database and BigQuery itself has some options for loading data right away, but we also seen that processing has a lot of there are scenarios where you want to process data. And typically that you develop that once and then you want to run it regularly. Think of, for example, the CSV that I mentioned earlier. Your application writes a CSV on a schedule on a regular basis, and that CSV is written to Google Cloud Storage. Now, from Google Cloud Storage, you want to load it into BigQuery. That's one action. You have to know somehow, okay, this has to happen at a certain period. You could tell your application to, after it's written the CSV, to also load into BigQuery. Well, that's kind of I would personally rather prefer decoupling this. Also, you might have multiple backends creating these, right? Which backend is then the one calling the shots on importing? And then also the kind of, for example, queries running on top of it, or the heavy lifting processing that you want to do with data flow on top of it. Who's scheduling this? Who's making sure that this runs automatically? This is what you need a dedicated service for. And again, with these services, you have 3 options that I would recommend when you're getting started. And the first one is Cloud Scheduler. Cloud simply trigger HTTP requests or pops up messages. That simple, really can't do much wrong, can't make much errors here. It's really straightforward. We're going to take a look in a second. BigQuery schedule jobs. Another nice feature of BigQuery, you can schedule a lot of kind of function stuff that you typically do with BigQuery from within BigQuery. Basically, BigQuery has a little scheduler built in. So you can automate queries or import jobs from within BigQuery. And lastly, Cloud Composer, another kind of like the gold standard tool for data analytics at the moment. Powerful and flexible workflow orchestration is what Cloud Composer gets you. We'll take a look at all these 3 in a little more detail. The first one, Cloud Scheduler. It's a lightweight and simple approach to trigger. You can trigger HTTP requests with any valid HTTP method. You can insert pops-up messages into pops-up topics. And you can trigger paths on Google App Engine services. So if you have these kind of admin routes on your application, this is Cloud Scheduler can trigger these as well. There's a couple of nice things about Cloud Scheduler that add on top. So of course you can say you have a kind of a timing. You can use it cron syntax, for example, to define your schedule. But you also have other approaches of like more verbal approach. You can actually say every Monday, for example, if you don't feel too confident with the cron syntax, you can write every Monday at 8 and Cloud Schedule will understand that. But you can also dynamically attach auth headers to your requests. So you define a service account that the Cloud Scheduler uses when it triggers the HTTP request. And this allows you to, for example, talk to serverless resources that are not public to the internet, right? For example, for Cloud Functions or Cloud Run, you now have a method like an IAM method to allow who can invoke this resource. And by attaching an auth header, this Cloud Scheduler can invoke this IAM secured resource. And also, you can trigger Google APIs. All right, all the Google APIs, you might be usually using a client library for this, but at the end of the day, it's a normal REST API or RPC API, right? With Cloud Scheduler, you can make HTTP requests directly to Google APIs with auth headers attached, for example, to start resources or delete resources every morning and every evening. But you can also use this in a data analytics fashion to run queries. So when to use it? Do use this to trigger individual compute resources. And that's really the key to this kind of a scheduler. When you have an individual task, but do not have a complicated workflow that run, then Cloud Scheduler is a really good option. If you have something like load data, transform data, run report, 3 steps, Cloud Scheduler, I mean, you can make it work. You load it, then 10 minutes later you have the next one, and 10 minutes later you have the next one. You step in your workflow. But there's no dependency between these 3, right? So if the first one fails, the second and third one is still going to try to execute. And also, there's no retrying logic or something like that on Cloud Scheduler. So don't use this for multi-step workflows, or also don't use this when jobs are changing regularly. This is a really that simple service. There's no version control on top of this. There's nothing that you can really check into Git to know what's happening if you're working on this with a team and everyone's working on that on different features at the same time. There's no way to merge stuff together, etc. It's really a straight, very thin layer, a very thin service. So when jobs are changing regularly, you might consider one of the other options I'm going to be showing you. The next option is BigQuery schedule jobs. I mentioned that already, right? You can run SQL queries or transfer jobs directly from within BigQuery on a schedule. This is actually pretty powerful because it already has dynamic parameters in queries to run, for example, controlled backfills and reruns. What do I mean by that? Well, think of a SQL statement, right? You have to select something from something where date equals today. So you're running this query just for today's data. Now you notice that last Tuesday, the original data was not complete, so you had to reload that original data, and now you want to rerun the query. If you are just put it today in the where statement, it's not going to work. With BigQuery scheduled queries, you can put like a Jinja template, basically, in the SQL, and when BigQuery is executing the job, it's going to automatically place the correct date of that run in the SQL string. Really, really powerful. You can do similar things with files with these data transfer services. So for example, load files from Google Cloud Storage, from typical reporting APIs, or even S3. That's a pre-built feature for that, to run that on a schedule every Monday, every day, every hour, every minute. So do use this to automate individual BigQuery tasks. Because individual, we have the same limitations that we've just seen previously. It's going to be, there's no workflow orchestration, no multiple task kind of thing. So don't use this for multi-step workflows. And also don't use this when jobs are changing regularly. Honestly, it's the same thing again. There's no version control on the queries that you're executing in scheduled queries. There's no version control on the kind of settings you're having. So be careful if you're having complex workflows that are changed, where a lot of teams working on this, or a lot of individuals are working on this. Maybe start thinking about a more stable solution, which is Cloud Composer. Cloud Composer is, again, a managed service for an open source framework called Apache Airflow. And this really is, again, I'm overusing the word gold standard a little bit, but I've seen so many organizations, data organizations, picking this up in the last couple of years. It's the tool for complex workflow orchestration. It runs on top of a Kubernetes cluster, so we have really controlled compute resources underneath. And you, in general, therefore also have full control of the network configuration. Composer allows you to structure complex DAGs, directed async graphs of workflows. So you can start with a simple task, then fan out to a lot of tasks that should run in parallel, and then reduce again to one last job that kind of checks or sends out an email, sends out a final report, something like that. You can go crazy with these kinds of DAGs. Fan out, reduce, fan out, multiple pieces in parallel. That's all can work really well. So when to use this? Do use it for complex workflows and tasks. For multi-cloud workflows, if you're having to load data from another cloud platform or from on-prem into Google Cloud, or have to load from Google Cloud to somewhere else, then this is a tool that gives you the right flexibility. And also, we've seen this also in the serverless tasks previously, if you have special networking requirements. If you do need that static IP, you can get it with Cloud Composer. If you do need to be on that internal network, you can do that with Cloud Composer. And when not to use it, don't use it for quick one-off solutions, and don't use it without taking the time to understand its specialities. Just like Dataflow, Cloud Composer is an advanced data engineering tool. It is really powerful, but you have to take some time to figure out why it's doing certain things the way it's doing it. It's not UI-driven, it's deeply code-based, which is the amazing things for an engineer, right? You don't have to do clicky something in the UI. It is a code-based service. But obviously, you have to learn a library. You have to learn the execution mode of this service. And, well, you need some time to figure out how to configure your service correctly, or your workflows correctly, sorry. So to sum it all up, we've talked about databases, processing, and scheduling. And I gave you a couple of options and examples of tools that you can use for these 3 areas. So database, honestly, again, sorry for not having more options, but if you're on the Google Cloud, take a look at BigQuery. Processing, stay as much as you can, as long as you can in SQL, and then maybe use a little bit of generic compute short term if it's really necessary, but be very careful with the kind of scaling limitations that you have in these kinds of environments. And then if you really need more, if your organization is growing, you maybe have some more engineers that can take some of their time to focus on data engineering tasks, start taking a look at data flow. And for scheduling, start off with something easy as Cloud Scheduler or BigQuery schedule jobs. Really simple to get started, has a lot of kind of pre-built feature set, large pre-built feature set for you. And then again, when your organization matures and your data needs grow, take a look at Cloud Composer and the gold standard for workflow orchestration. Thank you very much for your time. If you have any questions after this, I think that we're going to ask some questions now, answer some questions now as well. But you can always reach me at chris@doitintl.com. Thank you very much.
Awesome. Awesome. It was really good. And I hope that not only me enjoy this topic, and it's really nice session. Nice overview, nice deep dive. Thank you so much.
Thank you very much. Yeah.
Yeah. As always, we are looking forward for comments, feedback, questions. I can understand that it's not easy to go forward with the question, but if you have any, just mail them to us, use the Twitter, use the stream. We are always looking forward to help to get them answered.
Yeah, please reach out.
Yeah, you still have some kind of few minutes if you want to add something.
I think there's a question about the slides afterwards. Yeah, I'm happy to share the slides. I'm sure there's a method of sharing this afterwards. I'll definitely make them available from my end.
Good. So yeah, basically we are using the Twitter many ways, so you can find them there. Yeah, so mainly check the hashtag for the Twitter, and there is some slides from the trucks, and so people already share them. Yo. So looking forward for more questions here. Yeah, we have this opportunity. We don't want to prepare the questions and bump the speaker with them. So if you have some questions, please fire them here.
Yeah, and we also work in async mode, right? So follow-up questions are very much
we're ready
appreciated as
for
well.
asynchronous and synchronous and vice versa. Yeah, but thank you again. I hope if there is some questions, I will follow them to you directly, and then see you next time. Have a great day.
Absolutely. Thank you for having me again. Bye-bye.
See, ciao. Okay, what we have next? As I'm checking the website, we will have the next speaker up in 12 minutes. So there is a break, get some exercise, come back soon, and be there at 5 minutes of 3 p.m. See you. Hello, hello. We are here again. We are online, and this is our fest for the dev. And we are connected for the DevFest here online, and looking forward for the more backend, more development topics around the cloud and Google infrastructure. So right now, I have the next speaker here in my virtual studio, where I can see that there is the Ramon, who will talk about how we learn to code together remotely. This is super nice topic, really nice to hear and have him today. So welcome, Ramon.
Thanks a lot, Yevgen. Hope you're having a wonderful day, everybody. I'm super excited to be here and tell you a little bit about what we've been up to in the last year.
Okay, good. So please, audience, have a nice time here and get your questions ready. And Ramon, you can start the talk.
Alrighty. Hello, everyone. Thank you so much for tuning in today. This has been an incredible day with a lot of great talks, and I'm honored to be able to be here and tell you, as said, a little bit about what I've been up to. And the topic today is learning how we learn to code together remotely. So a bit of my background. My name is Ramon. I'm a Chilean software developer and developer relations contractor living in Vienna, in Austria. I've been doing this for 10 years now, and the name of the game is fun for me. As long as I'm having fun, I'm learning and I'm growing as an individual and as a developer and member of the community. And yeah, so my focus has been on Ruby, JavaScript, lately a little bit more Rust as well, which has been a lot of fun. And my main drive, my main moving forward factor is that of the software development community. I think we are so privileged to be around such extraordinary minds and motivated people. And I just love the way we learn from one another, the way we teach one another, the concept of learning by teaching. I think it's incredible. And, being able to do that has been really a lot of fun for me. I've also been a member of a program called the Mozilla Tech Speakers Program. Now it's more of a volunteer kind of thing, but it's a lot of fun. And it's been an incredible 2 years with them. I'm so grateful for every opportunity it's given me. But on to the topic. What is a coding study group? And the answer to that is, it comes with a lot of, it's not the only name for this kind of concept. It's also known as a hack and learn, coffee and code, kind of a learn together. And in researching this topic and talking to some friends, Joe Nash taught me that there is kind of an all-encompassing term for these kinds of things that also transcends different industries. So it's not just limited to software development. And this is called communities of practice. So what it is a group of people that get together in different contexts and talk and work together about all things in our case, software development. So, and it can involve a whole bunch of stuff. It can be, kind of co-working on side projects, holding mini workshops for one another, practicing talks in one another. That would involve this one as well, by the way. Also doing a little bit of show and tell, maybe show us, what you've been up to with your side projects and that sort of thing. And really the name of the game is encouraging one another, uplifting one another, learning from one another. So we have our own here in Vienna. It's called Study Jams. And it's been running now for almost 5 years now. And the way it started was my sister, Pilar, she also a software developer and DevOps expert. She attended a Rails Girls workshop. In case you're not familiar, Rails Girls is an initiative to help get underrepresented folks into software development, which for the most part used to focus on Rails, now has expanded into other sides. Well, anyway, she did this workshop and she thought, this is great. I'm so happy that I've got like a foot in the door. How can I keep this going? What's next? And that's where the concept of study jams came about. sort of a get together every 2 weeks where we would just get together and work on our side projects. And here's what it would typically look like, right? A couple of folks getting together. We were very kind to be hosted by Wikimedia Austria. So this is us in their office, just working on our laptops and talking, having a cup of coffee, having a cup of tea, some cookies, and generally learning and having a good time doing so. And well, due to a pandemic and a lot of circumstances from last year, we haven't been able to attend these in person anymore. And so what's happened to a lot of events and meetups is they've either taken a break for now while they figure out what's the best way to move forward, or they've moved online. And when moving online and looking at what other communities are up to, I happened upon a Rust one in Berlin called Berliners. And this is run, as said, by the Berlin Rust community. And they were really nice in offering this so that we could do it with people around the world. So I thought I'll join in. I'm interested in Rust, and we'll see what it's like. And it turned out to be a lot of fun. Excuse me. Well, so having attended this, I learned a lot about what they're doing, and I thought I could apply this to study jams. So we decided to move this community from being an offline in-person meetup to an online one in the meantime. And the question came probably on everybody's head is, what changed when we all went online? Because being online is very different when it comes to meeting with people over chat, over Zoom or something, or video chat. And my friend Flaky put it in a way that I just love. It's very different, not just because the environment is different, but because we ourselves are different, behaving differently. And it's got a ring of truth to it, doesn't it? You know, when you're attending your meetings over Zoom or your meetups over the internet, you kind of, it just feels different from being in person, doesn't it? You know, not just in the way you present yourself, the way you've got your camera perfectly angled so that the rest of the mess in your office is not shown, or, you know, the fact that you are probably dressed differently than how you would, you know, probably wearing comfy trousers, or, you know, a nice soft sweater, that sort of thing. It feels different. You talk differently. And so what I set out to do with Study Jams was to really address these points and see how I could make it as seamless as possible a transition. First comes in community dynamics. For example, when we would get together in person, we would take some time to catch up with one another. But when doing so online, there was things were a little bit different, because now people are joining in just once, maybe joining in for the first time. Given it's on the internet, it's a lot more accessible for folks who either don't have the time to commute to Vienna, or, you know, don't live anywhere close to Vienna, but still would like to join in. So we take some time to, as I said, catch up with one another, but also take some time to introduce ourselves, see what we're all up to. There's also, of course, dealing with technical issues. I think the most uttered phrase in the year 2020 was, "Can you hear me? Oh, you're muted. Oh, cute dog. Oh, look at your cat." That sort of thing. Oh, I think your camera. Oh, I think we lost that person. You know, that's that sort of thing that we've gotten used to by now. At the beginning was kind of like, you know, messing with the dynamic. This next one was a bit more personal. Long silences. When we were in person and we were, you know, each on our laptop, maybe working on our latest thing, it was kind of normal, or not normal, but but it wasn't uncommon for us to just sort of be in our own world, working on our own thing, but still nice to be around one another, you know, motivating each other. But when you're on the internet and you're sort of leading a call, I found myself a lot of the time kind of feeling like, are people bored? Should I keep the conversation going? Now, in the time since I've thought about this and given this talk before, it's come to my attention that this is, of course, dependent on culture, environment, and what I learned at the Rust Berlin Hack and Learn is this is just the same as being offline. People are working on their own thing and talk when they need to. It's kind of nice, kind of a co-working thing. So the other thing that becomes very important, of course, when dealing with an online environment is to keep a good eye on how we enforce our code of conduct. Because when we're on the internet, there's not just the spoken of video chat, there's not just the written of chat, there's also documents, there's also not documents, sorry, code sharing. There's a whole bunch of ways that we need to keep an eye that everybody feels included and safe. If you're wondering why we should even have a code of conduct at our event like this in the first place, I can recommend this linked blog post from Ash Dryden that I think tells it a lot better than I ever could. And the last part is that, we've got, now that we're online, the possibility to reach anyone in the world. Everybody can join in who has an internet connection and, the willingness to join. So that's the community aspect. What about the technical sides? What about the there's a word and it escapes me, logistical side? For example, now that we're online, there's nothing stopping us from taking notes in unison. So what I'm going to be doing next over the next portion of my talk is exploring some of the tools we found and used and just share how they worked for us. Now, when it comes to collaborative note-taking, probably what a lot of people immediately think of is Google Docs. Google Docs has this ubiquity. It allows people to edit documents together in real time. And it's very popular. But the problem I found was that, first off, I kind of wanted to give people the option of avoiding having to have a Google account if they don't want to work on a Google Doc. Not everybody has a Google account, and I want to be inclusive and make sure that everybody can join in. That said, I did find out it is possible to edit Google Docs collaboratively without a Google Doc. So there's that. However, we ended up going with a different option that was a suggestion from the Berlin Hack and Learn community, which is something called
we have some troubles facing technical stuff, and we will come back shortly if there is any feedback from Ramon. But I think we just can wait for the minute. Yeah. Hey.
I'm very sorry. I think I clicked on the wrong thing. My mistake.
No problem. Please continue just one few sentences before so people can sync again.
Yeah. My apologies, folks. I clicked on the wrong thing. Well, so what I was talking about just before I disconnected myself was that the possibility of HackMD is that it allows you to have collaborative note-taking. It's open source. It's the thing I was particularly excited about was allowing people to write in Markdown. I'm a big Markdown fan, so I was quite excited about that. And being able to write in Markdown is nice. Being able to write collaboratively is very nice. But what I also liked is that if you don't know Markdown, this also gives you the opportunity, like Google Docs, to have rich text like editing. So that was pretty nice. We ended up going with this and allowing us to link backwards, right? Link the document from the previous session, kind of gave folks like a look backwards at previous notes, see what we've learned and what we've shared with one another, links to projects, that sort of thing. Right. So that's collaborative note-taking. Then comes let's say the proverbial elephant in the room, video chat. Video chat, when it comes to these sort of things, is, I think, quite ubiquitous. As I said, I think everybody has used Zoom in the last year. So when it came to video chat, I wanted to take the opportunity to try something that wasn't just limited to video chat. And you'll see what I mean in a moment, because there's actually a lot of options out there. I'm going to show you a screenshot from my computer. This was the day that we sort of tested out all different platforms of video and audio chat. And yeah, just a ton of windows with lots of different platforms. And I'm going to take you through each of these and show you what we have here. So the first one is called Jitsi Meet. If you're not familiar with Jitsi Meet, it'll seem very similar to something you've used before, maybe Zoom, maybe Google Meet. It's a web-based video chat platform, and things I like about it: open source, You can host it on your own server, and it's usable with something called WebRTC, which is a technology that allows folks to communicate directly in the browser. And I really liked this. It was really exciting. We could have a certain amount of people. I think when I first researched this topic, I think the limit of people was something like 32. Not a big deal for us. We averaged on about 10 to 15, so it worked fine. When we started using Jitsi, there was a problem in Firefox, so it was better to use it on Chrome. Things like this that have been gradually being improved over time. Lovely platform, screen sharing, video chat. You can see there that one of us is with a cute dog, of course. Yeah, it's a lot of fun. So that's Jitsi Meet. What about something that's a little more, let's say, out there, something a little less common? We went with something called Mozilla Hubs. And I was quite excited for having an option to show this. Being part of the tech speakers, I was able to have people tell me about Hubs. And if you're not familiar with Hubs, it's a lot of fun. What it is, it's a platform provided by Mozilla that allows people to have virtual rooms and virtual interactions. Now, it is primarily made for VR, virtual reality glasses, interacting with the world, with the controllers and that sort of thing. But it is also usable on a browser. And so we thought, let's give this a try. And here we are hanging out in our Mozilla Hubs, let's say, session. And you can see each of us has a 3D avatar where this is a screenshot that I took with my avatar looking at the rest of everybody. Since this is a pretty open platform, you could have your own private room, hang out with people, choose a room, and even upload 3D models, 3D environments that you have created on your own. I think I want to say with Blender. I'm not very familiar with 3D modeling technologies. I'll have to look more into that. In any case, you can drop objects, you can take selfies, you can share your screen, of course. You can even share your webcam, which can be terrifying. I apologize for this horror scenario. Yes, that's me in the sky. You can see at the bottom left, Santa is looking up at me. There's something so ominous about this screenshot. I love it. We had a lot of fun playing around here. And the other thing about Mozilla Hubs that a couple other platforms have that I found really interesting in trying to replicate the experience of being in person is something called spatialized voice chat. Now, I just found this. I didn't know about this term beforehand, but now that I know it, I feel really clever saying it. Spatialized voice chat. What it is the concept of allowing avatars in a virtual environment to interact with with each other relative to their position in that virtual environment. By which I mean each person has, when they talk, they emit a sound. The closer you are to me in this virtual environment, the louder my sound will be. So you can have what this illustration here kind of tries to convey is that spatialized voice chat as a technology allows folks to be able to break off and have side conversations, which is really cool because it means that, say, a bunch of people are in video chat. If two conversations want to happen at once, what you really kind of need to do is open a separate room. But with spatialized voice chat, you can just move your avatars over to the side and do it there. So we were really excited about this. And we even set up a little auditorium. You can see there's my screen share, we put some dogs there. I like dogs. We put some dogs there to sort of follow along with us. And in the browser, the way you interact with the world, for those of you that are familiar with computer games, with first-person games, you move with the keyboard and you look around with the mouse, which was, if you're familiar with this sort of control, it's very handy. But we did find an issue where some of our attendees who spent less time with it had a kind of a tricky time understanding how to move in a first-person world. If you haven't spent a lot of time playing games, it's not going to be as intuitive to be like, one of our attendees, I remember, asked us, hey, where am I? I can't see myself. And I'm like, yeah, I tried to hold up a mirror to this person and be like, yeah, this is you. You can't see yourself because you're looking through your character's eyes. So that was really interesting and something that, gave us cause to think about other alternatives for people that are want to hang out in this more, let's say, chill environment, right? And somebody asks the question, does it come in 2D, two-dimensional? So instead of being a 3D world, it would be sort of a top-down world. And it turns out there are loads of options. The one that we found that was a nice open platform and recommended by the Berlin Rust Hack and Learn team is called the Online Town. Now, this is a little similar to how we have it in Jitsi. For example, you'll see here, here's our cameras. Here's a 2D world. In the middle there, you will see our characters. It kind of looks like, if you've played games like Pokemon, it looks pretty similar to that. We've got our characters, each of whom has a color correspondent to them, which is assigned to a key here. And those colors also correspond to our cameras down below. Now, what's cool about this is that being a 2D environment, we can also use spatialized voice chat here, meaning the further you move away, the quieter your character becomes to those people that you're trying to talk to. And so does your camera fade away. It becomes a little harder to see that person. However, this did have the drawback that screen sharing was not a possibility. That said, there are options for that as well. There's another project very similar to the Online Town called Gather Town, which tries to convey more of a conference environment as well. So screen sharing is totally a possibility here. So there are definitely options out there. Now you might be wondering, since we were 10, so on this day, for example, you saw in my previous screenshot, we were just 4 people. Now, of those people, you might be wondering, did we as a small group really need spatialized chat? And the answer to that was not really. It was a nice concept, but for our group size, our group dynamic, didn't really work. So that's fair. At the end of the day, we had a lot of fun, but we ended up going back to Jitsi Meet and carrying out the rest of our sessions since then at that size. And well, having explored all of that, I need to clarify, this is absolutely not an exhaustive search. These are not all the options out there. There are other alternatives, which I hadn't at the time looked into yet. A couple of them that came about are things like Kala, which is a plugin for Jitsi that allows people to have that spatialized chat. It kind of looks like the Online Town or Gather Town. For sharing code, it kind of reminded me of when I started out and I was doing lots of sharing TMUX sessions over the internet. Visual Studio allows folks to do live shares with one another using their editor to connect to other people's sessions of Visual Studio Code and code together there. We tried that with the Hack and Learn group for Rust in Berlin, and that was really eye-opening. There's also lots of other fun alternatives out there. One of my favorites is called Rambly. Didn't get to try it yet. And if you're familiar with the video game Earthbound, it's one of my favorite video games growing up. The style is very, very reminiscent of that. So I was quite excited to check that out. So all that said, the question then comes out, did we figure out the perfect formula for having online interactions and learning together online? Absolutely not. You know, we've been in this situation for just under a year now, and the need to be remote, you know, people are constantly coming up with new ideas. The technology is constantly advancing, but it kind of led me to a conclusion that I wanted to share with you today. And that is that maybe when trying to move these sort of things online, maybe I should try to be making it look less like this and a little more like this. So that's my talk for today. I had a lot of fun reading up about this. Here's some links to some blog posts, some deep dives into how WebRTC looks like, Mozilla Hubs, Online Town, Kala, Rambly. There was also a talk at the conference You Got This last week from Suze Shardlow about co-working online, and I learned a lot from that. Unfortunately, that talk isn't the recording of that talk isn't up yet, but keep an eye out on the website for You Got This. She did a great job of going into these topics as well. Lastly, there's this last link. The Introduction to Communities of Practice has a ton of really good reading about the topic of this, and I think we can all learn a little bit from it. So folks, thank you so much for tuning in today. If you want to get in touch, my Twitter handle is Hola Soy Milk. It's a terrible joke. It's Spanish for hello, I am milk. I do not apologize. Yeah, get in touch and see you around online. Thanks a lot.
Hey. So a super nice talk. Thank you so much. It was
Thank
like
you.
a pleasure for me. Super nice to see you, and what a vibe, what a like great surroundings, and like what tools did you select for the talk? It's really nice.
Thank you.
So yeah, amazing talk. Thank you again. Well deserved for go for the questions or some feedbacks. I
Cool.
see that there is a more than 5, I think, like really nice topic. So let's start with the question: have you given breakout rooms a try so that folks can connect to more than 2-to-1 or 1-to-1?
Yeah, we try. Well, I have tried breakout rooms before. The Ruby user group in Berlin uses these in Zoom, and these are great because you can you have smaller conversations. What they do at the end of after the talks of their meetup, they'll just randomly put people into breakout rooms, and this will allow folks to just hang out, talk about the latest developments in Ruby. And we just had Ruby 3 come out a few weeks ago, so everybody's talking about that now. Yeah, they're a lot of fun. However, unless I'm mistaken, they're a paid feature of Zoom. So if you're doing this on a volunteer basis, it would be good. I would recommend seeing if you can get some sort of sponsorship for your group, or so that you can have that feature.
Okay, so then there is a nice feedback about the backgrounds.
Yeah, I given this move to the online, being online so much, I kind of felt like I can't hide my inner Nintendo dork. So I'm kind of surrounded by it now.
Yeah, great one. So do you designate a moderator for the sessions? I think it's a context of this. Yeah, so you remember that part of the talk.
Yeah, that's an excellent question, and I should have covered that. My apologies. So the thing is, absolutely, in part of keeping with our code of conduct, it is absolutely imperative that we have a moderator checking these chats, checking the video chat, making sure everybody's feeling included and safe. And doing so as an organizer, there's only so much you can do, because because we are human, because we are biased, impossible to moderate yourself, and you will slip up. So having a third party to help with the moderation, to volunteer help with the moderation is, super important. Thank you for that excellent question.
Yeah, really great questions. And the next one, so we share, how do you share the code? For example, how do you collaborate on code? Do you use additional tools for that, or basically screen sharing?
Yeah, good question. That's a bit of both. We started out doing lots of screen sharing. I found that collaborating on code over these online sessions didn't happen as often as it used to, say, in person, right? So we were sort of just pasting snippets of code or sharing GitHub, what are they called? Links to very specific GitHub lines in a code base. Or what we've been doing more lately is also trying this Visual Studio live share. Of course, this requires having Visual Studio Code installed on your machine, but it allows us to share. It's kind of nice because it also lets you have your theme, your environment, your plugins if you want. In the past, I've done this with sharing Tmux sessions, though that's quite a few years ago. I haven't done that in a while. For context, Tmux is a terminal tool to manage your screens on the terminal.
Yeah, nice selection of additional tools and practices. So, and then nice feedback also about the keyboard and your background.
Yes, you might have seen some of that. This here is an Atreus. It's wooden. I've never waxed wood before, but they gave me, like, when I bought this kit, they gave me not just the case, but the wax and the sawing sandpaper. That's it. I like weird keyboards. I've got a few. There's probably see like one down here, and of course the one I'm typing with, which is an Ergo Docs, also with wood. I just like the feeling of wooden keyboards a lot. I promise not to geek out for too long about this. I love this stuff. It's a bit of a guilty pleasure of mine. Oops, sorry.
Nice.
Thank you.
Yeah. So we still have some few minutes for talk. So, or if you want to add something. Oh yeah, we have another feedback. So
Remote hurdle.
I call it remote hurdle. You have to actively signal that you want to share on this code. So it's I think the comment for the first keyboard that you show.
Thank you. That's a great term. I got to look more into that. Thank you very much for sharing Tech People code.
Yeah, okay. So checking again for the feedbacks and questions and just wait for 1 minute or so. Yeah, can't
Hit me
see.
up on Twitter or whatever if you want to chat some more about it. I'm very, very happy to chat about this stuff.
Please send us any questions. We will forward to speaker and then he can answer them and forward it back to you. Yeah, thank you so much. Thank you so much for your time. It was such a pleasure.
Thank you. Thank you for having me, and thank you all for tuning in.
Yeah, ciao.
Take care.
Bye. Okay, so we have, I think, 4 minutes for the next speaker. It's still break time. So get your body moving, get some exercise, and then we will come back with the last session for today. Yeah, see you soon. Hello. So this is our festival, and it's right in the end, but not really at the end, because after this, the last talk that we have in our track 2, we have the socializing event that will start in track 1. So please be sure to know how to connect to there. It's at 4:55, I think. I will also sync up after the Mario talk. Mario is the my friend who also work in a cloud environment, and he is co-organizer of a Munich cloud group. And believe me or not, but today we will see the demo guts that will show how to build CI/CD up and running in one of the GCP environments with the Kubernetes container world and all the engine tricks. So get ready for Mario. Mario, are you here?
Yay! Oh, I need to look it down because my camera is at the bottom. Hi.
Yeah. Hello. Okay, so how do you feel?
Quite nice. I mean, the weather was great last week, so we had snow. So yeah, this is something good. Yeah, but otherwise, a lot of work, how everyone can imagine, because of everyone now wants to go in the cloud, and we want to go digital, and we need to get this done because no one can go anywhere anymore. So yeah.
Yeah, true. Okay, so get ready for the talk, and now you can start your talk.
So hello everyone. I'm Mario. I'm a Google developer expert for cloud, and as Yevgen already mentioned, I also organized the Google Cloud Munich, Google Developer Group Munich for cloud, together with Yevgen. And usually we would meet up like every other month, but as you can imagine, it's kind of hard to meet up in person right now. So hopefully in the end of the year, we will have some more in-person events. You can find me on Twitter under this mfaland handle. So if anyone wants me to follow me, there you can find me or ask questions or whatever. But to get straight away, this was all of the presentation because as Yevgen mentioned, we are doing everything live. So I prayed to the demo gods in the morning that they will not be as bad as anyone hopes to be. So let's go into the Cloud Shell. The cool thing is everything that we do today, you don't need an editor for this. You don't need any previous knowledge in GCP for this. So the only thing you need is basically a Google Cloud account. And you can get a Google Cloud account basically for free, at least for a trial period. And all that I'm showing you today, you can probably also do with the always free tier in GCP, which is pretty neat. So how do I get here? So when I log into Google Cloud, you have like the Google Cloud Platform webpage, and there you have your interface. And when you go on this small icon there, you can activate the Cloud Shell. And when you activate the Cloud Shell, you end up needing to find the right window in this beautiful view, which is pretty neat because you have there a small VM, and inside of this VM, you can develop everything, and you have like an inline editor, which is also pretty cool. So there you can just create everything and have it inside a running VM. And now you would say, but how do I get my code into a repository? This is also brought to you by GCP, and it's included in there. You have the source repositories. In source repositories, it's basically like GitHub or Bitbucket. You have just a Git repository that you can use for your source code. So when we open the Git repository, I already created one. And there we have like one file that was put in there. You can there easily clone the file. So just insert an SSH key. Or if you create a new one, it also tells you what to do. So inside of the Cloud Shell, it's just a couple of commands that you can use to actually, open it. And I already missed it again. So basically what we can do here is, so that everyone can read it, you can just say gcloud, which is the command shell for Google Cloud that you can also download to your local PC. You can say gcloud source repository clone and then give it the name, and then just say in which project it is. So this is pretty amazing because you don't need to use like git commands and stuff like this to clone it. And then you have your source repository on your machine. So what else do we need? As we want to run it in GKE, so the Kubernetes cluster of Google, the easiest way to do this is we first need a cluster. So we go here. When you open this menu, you find a bunch of pinned things. But what we are looking for is Kubernetes engine. If you want to have it in a quick access on the top, the easiest way is just to press this little pin thingy to put it onto the top. So, and now we want to go to clusters. And there we can now create a new cluster. And for this cluster, when it's loaded, we can give it a name. And there's also the possibility to just use it in a really quick start way, or you can go deep into it to configure what configuration you want or you need in the GCP to run the Kubernetes cluster. So we will just do a couple of settings here. So first, the name of the cluster is now DevFest. And then we need to say where it should be placed. So we can place it either in a region or in a zone. What's the difference there? Each region consists of different zones. So basically, if you want to have a highly availability cluster, you would put it into a region, because then you have replicas in each of the zones. So when you have replicas in each of the zones, if one zone goes down for whatever reason, like power outage or something like this, the other zones will take over. If you place it zonal, you have the issue that only one zone is available and only one zone is having the, if there's an outage, you can't access it there. So, but we go for a zonal approach for the demo now. So we say we want to have it in Europe, and we want to have it probably in Germany, and Germany is Europe West 3, and we use zone B. Then you can say which version you want to have for Kubernetes. So you can have like a standard version or the newer versions. We go with the standard configuration for now. And now it comes to the nodes. So how many machines we want to have, and how big shall they be, and so on. So what we're doing now is we now say, I want 3 nodes, which is fine. We can put the nodes here again into a special zone. But for now, we just leave them there where they are, and we can automatically scale them. So if there are no resources left in this zone, we can scale them up so that they scale up automatically. So, and we can enable automatic repair, automatic upgrade, and so on. So, and now when we have a look at the nodes, we can now define how the nodes of the cluster will consist. So we can say, okay, I want to have like the machine type for that we want to use, like if it's more computing heavy or if it's more memory heavy. So you have different options. Be aware, the prices for this are varying, so always check out the price side depending on what you are using. So what we are using now is, because we only deploy a small Node.js application, so the smallest one is fine. So we use an E2 micro instance. They changed the name, like in the past they had other names, but for now we just use, we have 2 CPUs and 1 gig of memory. Also, we can say how many default storage it shall be, and we can add network tags, and we can add security accesses, and we can add metadata. We can automate things, but for now, for just getting started, we just go, please create this cluster. So this now takes some time. You see there we have now a new cluster, and it's now generated. So in this time, while this cluster is generated, we start with our small application. So, and to start this application, we go back to our Cloud Shell, and forever everything in Kubernetes is is defined by YML files. So we define in the YML file that we have like an application that is running, which is inside of a deployment, because we deploy it multiple times, or we can deploy it multiple times. And we also need a service to expose it to the public. So what we are doing now is we create a new file, and we name it deployment.yml. All right. So, and the cool thing in this Cloud Shell editor is you have autocomplete, and you have everything that you need for coding inside of your editor. So, and what we want to do now? So we want to do now a service, and we just use a specific AP version, which is in this case V1. And to define the service, we have now metadata, and we need to give it a name. So we give it the name server. Server is a cool name, and it gets the labels app, and we call it also server, because I'm literally not that great in naming things. So this is now, we have now a definition for this is a service. So this is the task of the service is to manage all of the replicas that we have, so that the traffic comes from one point and gets redirected to all of the services. So what we are doing, what we need to do now is we want to say where does it point to, what kind it is, and which ports shall be open. So we say we need a selector, and the selector is again server. And then we need to define which ports it should point where. So we can now say port 80. So everything that comes from HTTP, from the internet, shall go to with the protocol TCP, shall go to our target port. This is where our application is running onto inside of our Docker container, 8080. And our type, what we are using here is a load balancer. So it balances, so it basically checks which port has capacity free and then routes it to this point. And that's it. This is the complete definition for load balancing your first application. And the next thing that we can do now is we now need a deployment. So we now need to define, I want this application with this objects onto this machine. So onto this Kubernetes installation, and we can now put in there, we need the version 1, and we now want to have deployment. It also needs some metadata, as we now know. I'm a friend of naming everything the same, which sticks together. So it also gets the name server. It also gets the labels for server, and it got a specific spec. And as you can see, it helps me writing all these things because you have like all of the autocomplete, and it highlights you when you have made some errors or there's something not working or not valid. So this helps you already. Usually you also find add-ons for writing YML in all of the various editors. And there's also for VS Code and for IntelliJ, there's the Google Cloud plugin that you can install. So this also verifies if everything is written correctly for Kubernetes, because there you have like the autocomplete for your environments. So, but we and now the important thing for these labels, what we defined, comes up, because now we tell him where it should match, so that service matches to deployment, basically. Sorry if it's weird if I always look up, because on top of me there's another monitor, and I usually check the images there if everything is okay. So we now need to match a specific label, and the specific label was for is for app, and it is as we called it, server. All right, and now we need a template. So the template tells us also the labels again, which is server, and the template tells us the spec of our container. So we'll give it the name server, and it tells you there define what is the spec of the container we're using. So it also needs an image, but we don't have an image yet. So we just say, oh, it's a placeholder. This is fine. And we need to tell him on which port it's running. And as we know, we want, because we use the target port on 8080, it tells us now, okay, I want to reuse, the containers are running and exposing port 8080. And the cool thing is, as you can see here, you have like, not only the autocomplete, but you have also like an inside documentation that tells you what is the thing that you just wrote and where you can find everything. And so that, yeah, basically it helps you just to write all these things. And now we have our container ready, which is pretty neat. Our deployment ready. And now we need a container. So we need to get our container up and running. For this, I prepared a Docker file. New file. Docker file. And because I'm lazy, I'm just pasting it in. So this is a standard, a small Docker container that is just doing npm. It's choosing Node.js. It's doing an npm install, and it is starting the application. And we shall expose it on the correct port. So this is better now. All right, and now we need some kind of application. I already prepared something of this. So we need a new file, and we need an app.js. And inside of the app.js, we just have an Express server. And also we need a package JSON. The good thing is everything that I put in, that I show you here, I already put into in a GitHub repository, so every one of you can just grab it and test it on their own if you like to. So new folder, and we want to call it binary, and there we want to start our server. And now we just need some 1, 2, 3, 4 more files, and everything is fine. This is the problem with demos. When you do them remotely, you need to create everything again. I mean, I could just check everything out, but this wouldn't help you at all. So user controller.js. It's just, yeah, it's just telling us, oh, this is the wrong one. My bad. This one. So we have like just separate endpoints that getting us some student records so that we can basically call specific routes in the end. And as we know, everyone in the world needs tests because we all do test-driven development, right? We also need a folder for tests. So we create a test folder, and we put in a new file in there, which is called test.js. And so we have like some tests that are running, because what our goal is, we also want to test things in our build process so that we can have a full CI/CD pipeline, because nothing should go into the internet untested, right? And now we need also a new folder for like our front ends, and we can there create 3 new files, which is error.pack and index.pack and layout.pack. So we just put in some layout there so that we have like base page and we can open everything, and now we only need now the routes. So we say routes, and we have like index.js for our routing, and we have like users.js. So this is just an easy router that basically renders us our index page, and we have a router for our REST endpoints. All right, so everything is now in place, except one thing. So we have now our deployment file for Kubernetes. We have our simple Docker file. We have all of our JavaScript files that we need. We have a package JSON to basically install the dependencies for our app. But we need something more. And this is now the point where we get to the Cloud Builder. So if we go to the Cloud Builder, you can find it down below at under Tools. You have the Cloud Build. And also we see now our clusters up and running. And in Cloud Build, when we go here, we have a dashboard. And in this dashboard, you see all of your builds. But what we want is, we want a new trigger. So we want every time someone commits something into the master branch, we want to have our system built and deployed. So we now need to create a new trigger. And we call it DevFest. DevFest application. And it should always trigger when I push to a specific branch onto my repository. If you use GitHub, because you're not limited to use Cloud Repository, you can also use Bitbucket and GitHub as well. You can even build it as soon as a pull request is created. So basically, you can use Cloud Build to deploy it to your Kubernetes cluster for testing purpose if everything is all right with the pull request. So we can now select in our in source, we can now select out of our cloud repositories our repository. You can also say, I want to add a new repository, and then it tells you you want either to use Bitbucket or GitHub, and then you will just have to give access to GitHub or Bitbucket. So, but we don't want to do this because we already have it. So we just say we want to use DACH 2021, and we want to build it the master branch. And then it tells us, you have two possibilities. The first possibility is you can build it from a Docker file. The problem with building it from the Docker file is you just build a Docker image, but we want to do some things more. So we don't only want to build a Docker image, we also want to build the image, first test the application, deploy the application, and then in the end deploy the application. And as we haven't created any services yet, it should also create the service. So what we do now is we want to recreate now this cloud build YML file. So it tells us, okay, there's a configuration file we can use, and to create this file, we just put it into our repository as well. So we say new file, paste the name in there, and say, yeah, I want a cloud build YML. So what do we do in there? Basically, this is also a YAML file that you can say, okay, I want to do it in steps. And the good thing is, if you now do it in the Cloud Shell editor, it has also the autocomplete tell you what is available and what not. So we have different steps. So we can now say the first step we want to use is we want to use from our from Google, from the cloud builders. We want to use npm. So we can now say okay, please do install. What it does is it basically runs an npm install. And then we want to do an gcr.io/ the next time I will copy it. It's way faster than me. We want to do an run test. So we can say run test. So this runs now npm test for us, which is pretty neat. And because I am really, really lazy, I will, and to speed things up because no one wants to watch me typing, we can now say I want to be, if this is running fine, copy paste is always a bad thing. We want to do a Docker build. So what we are doing now is we are now running Docker build, and we can give it, I think I hope everyone hears me. And we can now do an Docker build, so we can give it variables. So as you can see, there are fixed variables like project ID or repo name. We come to this in a sec. And then we just run a Docker build. And for the next thing, we want to push it to our Docker registry. The good thing is here we have a built-in Docker registry inside of GCP, so we can just use this one as a Docker as our Docker registry. And afterwards, we need to apply the deployment file to our cluster. So if you're interacting with Kubernetes, you always are using the kube control shell, as a kubectl, and you can run this either in your shell. So I can here run a kube control, or, which is pretty neat, we can just run it inside of our deployment file. So what we're doing now is we say we want to apply the file deployment YML that we have in our repository. We come in a second to these things because they are relevant. But you can see the difference. These ones here start with a Lodash. This is something to keep in mind. And afterwards, to change the image, which is missing in our deployment YML, as you can remember, because we said we don't have any clue where the image is, so we can't use it yet. We can now, as a last step, say we want to set the image of our deployment that we put into our Kubernetes cluster. So we have created everything, and now we can create our trigger for this. So as you can see here, we have variables. Maybe I can switch it to English. Give me a second. Lang en. No, doesn't work. This is still an error. Still a bug that you can't switch to English when your account is German. So you have like the substitution variables. So which means you can there put in custom variables that are put into your cluster. So what we are doing here now is we have now the possibility to give own variables, and we need 3 of them. As you can see, your custom variables need to start with a Lodash. So this is what we did here. So we have here like deployment. And we give the deployment the name server. Why do we give the deployment the name server? Because we called the application in our the deployment in our we gave it the name server. So we just say this is our this is the name of our deployment. I mean, you can hard code it inside of the file, but in this way the file is more usable, which is pretty neat. We don't need the project ID because the project ID is always substituted in the cloud build, or as well as for the repo name and as for the build ID. So we always are sure that this is the project ID where our project is running inside of GCP, and it always is the repo name and how we named our repo. And the build ID is generated for each build. So we know each build generates a next unique ID, which is pretty amazing. The only thing that we now need to do is we need to tell it where is our cluster. So we give it we set the name to the cluster zone, and the cluster zone is easy to find because this is the zone we gave it. It was in Europe West 3B, or where we put it. And what else do we need? We need a cluster name. Of course, it needs a cluster. Where does it go to? So the cool thing is that we can, if you have like, with this file, and if you have like multiple clusters, like one for staging, one for production, one for testing, so development, you can just copy everything. The file stays the same, and you can just define inside of the build triggers where to go. So you have a multi environment deployment as well, which is amazing. So the last name is cluster name, and I think we called it DACH. Yes, we did. DACH. All right, and that's it. I reloaded it. My bad. I'm stupid. DevFest. All right, and now we go. You can now jump directly into it. And now we say, we need to go into the, I hope it's big enough. I'll make it a little bit bigger, so it's better to read. So we go to DevFest 2021. And here we have all our files, and we have some new files. So we say git add something you should never do, but everything is fine now. So git commit -m, and we want to give it the name. In no time, this is running on GCP. And we push it. And now that we push it, yes, please, to our repository, we have now all of the code inside of our repository, as you can see, which is pretty neat. Sorry for this. So we have now everything there, And if we go to our dashboard, we have a new build running. And it failed. I upset the demo gods. I knew it. All right. What did I do wrong? So, which is pretty neat. Now you now see all of the build steps that we defined in the file. So we have now our npm install. We run our tests. So we have like the test that we usually run locally, run inside of the Cloud Shell, and it's passing. And yeah, and then I did something really, really stupid as naming the, the repository in capital letters. Yeah, my bad. So let's quickly try to fix this. I hope my time is running out. So this was when you upset the demo gods. So we want a new repository. We want to call it DevFest and give it into this project, please. Thanks. And we want to this is the easiest way. So you see here that you can easily just copy the commands to initialize everything. So maybe it's easy so that we can say, yes, please. I want to use this account. Thank you very much. And I wish to use this project. And no, I don't want to configure any zones now. And now we can say, hopefully we can this just works for us. So we can say this. Demo gods. I upset them. Maybe this is working. Maybe this is working. Let's have a quick look. So we go to not this one, but all repositories. Come on, come on. Lowercase DevFest is working. Yeah, we have the files in there. So we go back to our Cloud Builder and we want to go to our triggers. And we want to change this to something that is not bullshit. And no, I need to copy the trigger. This is sad. Okay, new trigger. We want to use the DevFest, which is camel case. This is DevFest. Correct. And we quickly need to put in the variables, which is deployment, which is server, and tuck, tuck. And then we need to push in everything which is in here. Cluster zone. And cluster name. And cluster name was DevFest. And your REST 3B. And now we go. And the good thing is it already is pushed. So you can always say, run the trigger. And you can also then change the variables, which is a new feature that came out not so long ago. So if we go now into our triggers and we see now our build, we can actually watch it, what it currently is doing. So the test passed. So we are basically now at this step. And you can now see it's now pulling the image and it's building the image. Come on. And now it's still building the image. It's tagging the image now, as you can see. Oh no, probably you can't see because it's way too small. It's tagging the image. And we now have this image tagged. So if we go parallel into our container registry, which you also can find under Tools, the container registry. This is what I told you. So we have like the container registry, and inside of the container registry, you can now find the image that we have just created. So you can always download your images from there, which is pretty amazing. And while this is doing, we have now pushed everything to our registry, as we saw. We also have now the servers created and the server created. And there we have an error because I probably mixed something up. But what we can do before we check for the error, if we have a look here, no, I don't want to have this information. We can now look into our cluster. And I don't want things. So when we now have a look in our cluster, we already can see that in DevFest, we have now a new deployment, which is called server, which is obviously not running because the last step was not running, because he couldn't find the image. But what we also have is we have the server created in our DevFest cluster, which is now a load balancer with an IP address that we can actually open in the browser, which would show nothing because the image is not there. So let us quickly check what the demo gods did wrong there. And deployment, probably I just didn't write the thing correctly. So if we go to our cloud, in our details, we can now have a look at the triggers again. And we have a look there. This is right. This is right. Because the error that told us was this was wrong. So let's quickly check the code again. So we have our deployment. It's called server. The app is server. The labels are server. And the containers are server. And what was the error that was told us? Let's have a look. yeah, didn't set the environment variable for deployment. I guess I just named everything wrong. So we have a look again at triggers, and we have a look at, no, I looked in the wrong one, my bad. We have a look at there, and deployment, yeah, and server T. Deployment and server T is definitely the wrong variable. So if we have the right name, am I in the right? So this looks better now. So we can go back here, build again, and no, the wrong one. No, this is the right one. And we go. And when this is running, and when this is run through, it should deploy our application to our server. But this is now only waiting time. So what basically do you need? You need only a browser. You need some kind of application. In my case, it was a Node.js application, but there are a lot of things that you can already use in there. For example, if you write Go, you can use Go to run it inside of the cloud build. You can even define the size of the building machines, but only with the small building machines you have it in the free tier, because you have, like, I think it is 60 minutes every day for free building time. So where you don't pay anything, which is pretty cool. And I mean, you see how fast the builds go. I mean, even the bigger the image, the bigger the builds will go. But overall, this is basically everything that you need. Also, you can have a look at the resources that will get used or that are available inside of the Cloud Builder. So if you go to this website, you see all of the builder libraries that you can use inside of Cloud Build. So you see, you can also do a Git checkout. You have Go, you have Java, you have kubectl, you have Maven, you have NPM, you have a bunch of things, and you can also use your own libraries to build inside of this machine. So what you can also try is, I think that Docker is also available. So basically what you can do is you can set up inside of this machine a Docker container for like a database to run your tests against this database. And as we saw now, our build was completed, and it set the image. And when we have a look at our repository here, we now should see a new image. And when we look at our server now, we have now a cluster that is running. And we have now our container that is running. And we can have a look in the logs of the container. So we see like right in what's going inside of the container. I don't care. So you can now look into the logs in what is inside of your container, but there's nothing that is basically now logging. So, and if everything was right, sorry for this, Kubernetes engine, we want our ingresses. Maybe if my application was good, we can see something. No. But It's creating. Oh, yeah, because we now have 2 deployments as I create. No, it's still creating the containers. Okay. So probably I destroyed my. Okay, the container crashed. So remove this, please. And I think okay, we destroyed our image, and he's now trying to recreate it, everything. So this would take some more time, but the deployment process itself just run through. I probably just had an error in the application itself. But this is an easy way how you get all up and running in GCP. If you have any questions, I'm happy to answer them if there's time.
There is some time always for the questions. So thank you, Mario, again for this demo talk. That is really nice. I think that what we need to do once is the sharing the your repository for the
Yes.
You
Give
can
me a
share this in Twitter. Also use the.
I will share it on my Twitter account. Yeah.
Yeah, good. Then, as I can see, I will checking the things around. But while you are sitting here, please, can you show that? Like, tell me about what is the next steps for this talk? Like, do you want to prepare next demo sometime in the GGG community?
Honestly, the next talk for this is how you get everything that we just did in GCP without GCP. So we have there are a lot of people, especially in Germany, that are working on still in on-prem environments and have a hard time for using Kubernetes in on-prem environments or mixed environments where you have like a master cluster running in, let's say, AWS or GCP, and they have like a seed cluster running in your local environment on a vSphere or on some bare metal machines. And everyone that has gone through the process of setting up Kubernetes itself manually knows it is a pain. And the company I work for, we created an open source product, which is called Kube1, which basically helps you to install Kubernetes anywhere. And the next thing would be there that we can have a complete CI/CD pipeline running on your own on-prem Kubernetes cluster with Minio for the image registry, and we use the Canico builder so that you can build images, Docker or Containerd images inside of Kubernetes. So you basically have a container builder in your container. And this would be the next thing to go, because I think that a lot of people use like this pre-installed Kubernetes platforms, but especially for the German or Austrian or Swiss environment, it is always kind of heavy because of regulations running in public clouds or in clouds generally. So a lot of them are still on data centers, and they also want to have like this Kubernetes approach so that you can scale up and scale down your environments and containerize their applications.
Good, right. Okay, thank you so much for answering this. It's a really nice way to forward. So again, I can't see any more questions here, and I'm really thankful for you and for audience for this day. What we're gonna do next, I also invite you to go for the track 1, where we have social session. Also, we'll close the session. And yeah, please join us soon. See you there.
Have a nice evening, and thanks for having me. Bye.
So yeah, okay. So let's go there in a track 1 and see you soon.